Less than 2 hours ago, U.S. Space Shuttle astronauts began their fourth spacewalk mission to repair the Hubble Space Telescope. Astronauts Kathy Thornton and Tom Akers are installing a device designed to allow Hubble's optical instruments to see straight. The device, called COSTAR, is in a box the size of a telephone booth. And CNN International will bring you extended live coverage of the Hubble repair mission in about 25 minutes.
Those were P's I was taking off. They just weren't labeled. The label is all J. Now it's got a P4. You can see a label. Okay. All four connectors are loose story.
All right, can you pull me down and out, please?
If the ground's down and out, Kitty. Torque of 10, power tool on 3.
And welcome to our live coverage of the Hubble repair mission by astronauts from the U.S. Space Shuttle Endeavour. 2 astronauts are on the 4th spacewalk of the mission. They aim to fix the nearsighted telescope. And joining us now, once again, is CNN's John Holliman. Welcome back.
Bettina, it's good to be here. The astronauts are having a pretty good run of it in space. They've been out in the cargo bay of the shuttle for about 35, 40 minutes now, again getting an early start on the mission. Here's the live picture from space right now. What you see there is, on the right of your screen, astronaut Tom Akers, who's the free-floating astronaut tonight, not hooked up to anything other than wires, which NASA calls tethers. On the left of your screen, it's fairly difficult to see, is the robot arm and astronaut Kathy Thornton. The blackness that they are looking into there is the center of the Hubble Space Telescope. There are 4 electronic instruments in the center of the telescope that have been providing astronomers with about half of the pictures that we have seen from space since the telescope has been there. And one of those 4 instruments, something called a high-speed photometer, basically a counting device that will count the frequency of light from stars, is going to be removed. And when that box comes out, it will leave a hole in the telescope about the size of a telephone booth. And the final set of corrective lenses for the out-of-focus telescope is in a box identical in size to that box. The astronauts will be plugging that in the next 2 or 3 hours. Let's listen for a minute as the astronauts talk about what they're doing and see if they're having trouble or if it's working just fine.
Sliding the high-speed photometer
Plate here. It looks like a front plate.
along its tracks.
Any higher than the A-latch mechanism and C are going to be. I think I see a cavity behind it. We may be okay.
Am I coming out close?
Okay, coming out.
Coming out close, or stop.
Okay.
Providing extra light for the crew is Mission Specialist Story Musgrave shining a flashlight through the back windows of the orbiter's cabin.
And then stop.
Stop. Lift left roll. Looking good, KT. You can see down on the rail there, right?
The Endeavour space shuttle, Bettina, is over darkness right now. It's in darkness, and so in order to see into this cavity inside the space telescope, they have to have a little light from outside. The light that you see, which sort of looks like a flashlight shining on them, is in fact a flashlight that's being operated from inside the space shuttle by astronaut Story Musgrave. He's holding it very carefully in his hand and pointing it where the 2 astronauts outside can best use it. You can see the outer edge of that piece of equipment that's going to be removed tonight right now. The astronauts have to be very careful about getting this instrument out because they don't want to damage the cavity in which the new instrument's going to go. In order to take it out, they're going to have to disconnect some electrical connections. They're going to have to disconnect a grounding strap, as they did in the spacewalk last night with the other main camera for the telescope. And Kathy Thornton on the robot arm will be very carefully backed out of this position as she pulls out this high-speed photometer. It'll be stored as the big camera was last night on the side of the shuttle until the new instrument's installed.
How will the new instruments work? What exactly are they doing?
Well, they have newly ground mirrors that are ground with the opposite prescription of the main mirror of the telescope, and those mirrors will fold down. It looks sort of like a Rube Goldberg device, really and truly, Bettina, but NASA says it was the best fix for this problem. Those mirrors will come into place in a matter of a few hours, and then we'll see whether they work. Our coverage, of course, will last throughout the 6 hours of the spacewalk.
Okay, let's watch and listen.
Probably going to be out of the Delron by now.
Like, Tom, look at the safety tether down there.
Okay? It's going to be okay, KT.
Oh, okay.
Yep. It's going to be all right.
All right, Clyde, let's keep coming back.
Yeah. Okay, coming back now. That was me. Okay? But I'll get it down just a touch lower for you, okay? To be sure. Hey, you're out on the outer rail, KT.
Hey, how's it looking?
Let's just hold down and a little left roll, and you're doing good. You're starting out of the cavity.
Hey, it feels good. I think I'm going to be okay.
All right, just keep holding down and keep it over on my rail, because I don't think you have anything up high.
Can't see anything
No,
anymore.
you can't touch it. It's so much higher. Get 2 inches higher than the Delron channel.
Okay.
Okay? You've got about 2 feet to go, and you're looking real good. I just keep going, KT.
Hey, keep coming, Clyde. Good rate.
Perfect. Perfect. Now just keep straight on going. Looking good. Hold down on it. Now you're starting to come off the rail, so take everything out. Okay, you're free of the rail.
Hey,
Okay, you're pitching back in a little. Pitch up a little.
coming, Clyde.
No, pitch up a little too. Just keep going. Keep going.
Coming, Clyde. Keep.
Okay, you're clear of the cavity. Now this is increase the rate somewhat here, Kitty. Okay. Good. Yeah, it's pitching. The top's pitching toward me a little bit, KT. It came out. Better right there. Okay. Looking good. Why don't we stop right there, KT? I'm comfortable with
Hey,
that.
stop here, Clyde.
Okay, stopping start. Let me see if I can get in position to watch you come back in within about 6 inches or so, and we'll look at it. Didn't touch anything coming out of the shroud there. It was good. I'm going to ease back. Put my safety tether under here.
And you're watching here astronaut Kathy Thornton. Kathy Thornton with this spacewalk will be the only woman who will have 2 spacewalks on her resume when she concludes this spacewalk. And she's right now working to get this equipment out. The equipment that will be installed on this spacewalk cost some $50 million. It weighs about 340 kilos and as John told us earlier, has about the size of a telephone booth, some 2 meters tall. And if you listen to what the 2 astronauts are talking about, you can see what a difficult job this is and how careful they are.
Practice run with the high-speed photometer, now that it's been removed. Practice run for what they'll perform installing the CoStar corrective optics package for the telescope.
But just keep it right where it's at if you can. Okay, it's coming in good. That's a great rate. Great rate. If you need to roll left south about 2 or 3 degrees. Okay, that's good. Good. You're rolling in the ball. And let's stop, Claude. It's stopping. Okay, we're about 10 inches away, KT. Okay, if I ask you to bring it up a half inch, try that. That's great. Okay, if I ask you to pitch up a little bit. Great. Okay, pitch down a little bit. Okay, stop. Okay. Well, you put roll in for Claude, so that's good. How about a little left jaw? Okay. That's good. How about just pure right motion? Great. How about pure left? Well, I've asked you to pull it back.
We'll have more of our live coverage of the Space Shuttle repair mission of the Hubble Space Telescope after a short break. Stay with us. And we are back with our live coverage of the Hubble repair mission by astronauts from the US Space Shuttle Endeavour. 2 astronauts are right now taking a spacewalk, their second overall, the 4th spacewalk of this mission. It's Kathy Thornton and Tom Akers. And they are right now working and trying to fix the nearsighted telescope. Let's watch and listen.
Outstanding. Roll is completely open.
Center, and this is a live picture.
MLI, the catch coming in or out. C-latch is clear. All the tape is down tight everywhere. It is top possibly going to touch the MLI a little as we go in. If that co-star corner is the same height as that piece of metal sticking up on the front of HST, that inch and a half or so.
Kathy Thornton and Tom Akers, the two astronauts that are working here right now on their spacewalk, have the task to install a very tricky device that will intercept incoming lights and corrects it before it hits 3 other Hubble optical instruments, all of course part of this mission to repair the $1.6 billion Hubble Space Telescope, which has had a long row of difficulties, and NASA is trying very, very hard to fix it. And you're watching live picture from Endeavour right now.
Yeah, you're well clear, KT. You're in good shape. Be kind of nice to know if we wanted to, whether it would, kind of hold up, have some give to it. You need light, KT? That help, KT? I guess, Joy, I could check it out when I come back the next time and keep working here. What do you think?
Okay, how about left?
We're waiting on the answer
Left
from you.
position. Four. I think he can bring me straight down.
Endeavour Houston, if Tom could give us a couple more words to clarify exactly where he wants to push, that'll help.
Okay, Greg, it's exactly in the place where the bolt stuck down and kept co-star from going in the high-fidelity mechanical.
And John Holliman is back with us here. John, what's happening at the moment?
Right now, the astronauts are inside the telescope, or at least one of them, Tom Akers, is actually inside this telescope. As you know, Bettina, it's 43 feet long from end to end, and that's about 12 meters long and a couple of meters across. And so there are parts of it where it's possible for a human being to occupy some space. And Tom Akers is there at the bottom of your screen inside. And as he continues to do his work of unhooking a couple of latches that hold the high-speed photometer instrument in place, Kathy Thornton on the robot arm is at one end of this telephone booth-sized box. The plan was for her to be at the bottom and Tom Akers to be at the top.
So they changed positions?
Yeah, and that unless the picture we're looking at is upside down from the perspective of the telescope itself, and that's possible too. The camera that's being used to give us these pictures is itself attached to the robot arm. But from what I can tell, I had to go away from our international viewers here for a minute to bring the CNN domestic viewers in the United States up to speed. And it appears that they, as they have been all along, are a little bit ahead of schedule right now. You remember 2 nights ago, we talked about a problem with the doors on the side of the telescope. After the astronauts got the doors open, they couldn't get them shut again. And so tonight, when they opened the doors for the first time, they tried to do a lot of different things from what they had done before to make sure the hinges on the doors didn't spring or deform in some way.
So are those always the same set of doors?
Nope, different set of doors this time. But as the doors came open tonight, immediately it appeared that they were going to have a problem getting these doors closed as well, despite their extra care. So this, you can see the robot arm itself there, covering up the center of your screen. And there's a light attached to the arm. Astronaut Tom Akers visible with the American flag on his back. Actually, the flag is in shadow now from the arm, but we'll see him and it. Again, you can see the word NASA just behind the CNN International sign on your screen. And so he's at work at his end of this instrument, the high-speed photometer.
Who is controlling the robot arm?
Claude Nicollier, the Swiss astronaut from the European Space Agency. As you know, the European Space Agency cooperates fully with the American Space Agency, NASA, on the Space Telescope project. Astronomers from all over the world use the telescope. And the European Space Agency supplied the solar panels, which were replaced a couple of nights ago. And they've supplied one of the other instruments in this compartment where the astronauts are working. It's called the Faint Object Camera. And what it is able to do, or what it will be able to do after tonight's spacewalk, if it's a success, will be to focus on light from things so far away that they can't be seen from the Earth, period, even in an unfocused way. That particular faint object camera will discover stars that have never before been seen by humans if the replacement unit is installed and works correctly.
Now, we should point out again, despite the flaws of the Hubble Space Telescope, it has been working. What has it been doing, despite the flaws?
Well, it's been taking some pretty good pictures of the planets with the instrument that was replaced last night. The Wide Field Planetary Camera is designed, at least for part of its mission, to look at the planets in our solar system. And it's been able to do that. And the pictures are pretty clear. We showed our viewers last night, you remember, a photograph of Saturn that was clearer than any astronomer on the Earth has been able to see Saturn. And so that instrument has been working okay, but they expect the pictures to be much more clear after this repair mission. And the other instruments, like the faint object camera, really hasn't been very useful at all, because it had to be very much in focus to take pictures of these faint objects far, far away from our galaxy and our solar system.
How far away can they take photos?
In light years, about 3 to 4 million. And what they want to be able to do is to do it 15 to 20 billion. And if they can do that, they say, they'll be able to see the beginnings of the universe as we know it. It's hard for me to conceptualize this. Let me tell you what's in the picture now. You can see the feet of astronaut Kathy Thornton filling up most of the screen there, as she is on a footrest at the end of the robot arm. The robot arm is now moving up to the top of your screen, and she is, I guess, at this point going up to the top of the telescope area where the repair work is going to be done tonight. It sounds like the astronauts are finding something they didn't expect to find. Astronaut Story Musgrave is shining a flashlight into the area where Tom Akers at the bottom right-hand corner of your screen is working. Why don't we listen and see? Akers just said that there was a piece of plastic wrapped around something that he didn't expect to find when he got in there. Well, we've lost our picture from space for just a moment. The reason these things happen, these little periods when our picture from space go away, is that the communication satellites, good as they are not perfect. And sometimes the space shuttle itself has to change its direction from where it is just to keep the astronauts' bodies warm. They have to shift the shuttle subtly every so often to make sure that they don't freeze to death out there, because it has to be in the right orientation toward whatever heat sources there are to keep the astronauts going.
Well, while we wait for the live pictures to come back, let's take a short break. We'll be back in a moment. And we are back here with our continuous live coverage of the Hubble repair mission in space. And with me once again, John Holliman. We just heard a moment ago there might be a little surprise here.
Yeah, one of the astronauts, Tom Akers, out inside the Hubble Space Telescope, was trying to disconnect an electrical wire from the side of an instrument from space, and he had some trouble getting to that wire, and he said he was surprised because there was some plastic covering this part. And we haven't heard back from the astronauts to see how well they solved that problem, but these are some of the problems that they talk about wouldn't appear to be problems to the two of us. If you open your kitchen cabinet and you see that the pepper container is in front of the salt, you move the pepper container out of the way. Inside the Hubble Space Telescope, moving the pepper container out of the way is something you got to talk about a lot with ground managers to make sure that everybody agrees with you before you do anything inside there. The astronauts, in all their preparation for this, have said the most important thing to them is to not break the telescope, not make it any worse than it was when they started. And that's why they're being so meticulous and so careful as they work inside there to make sure that before they move the pepper shaker out of the way, the ground controllers all say yes. I guess shared blame is a good thing in case that pepper shaker were to destroy the telescope in some way. There's something else they're going to do, by the way, besides adding the new corrective lenses tonight. There is a computer on board the Space Telescope that is a 1970s vintage computer. It's, for people who know about computers, it has a 286 processor in it, which means it'd be okay for a home computer, but it doesn't compute very quickly. And it also has a bunch of memory chips, and about half those memory chips have stopped working, which means that the amount of information it can store is about half what NASA wanted it to be. Astronaut Story Musgrave did an interview tonight, and he said he thought the reason for the damage to those computer chips might have been cosmic radiation. So what the ground managers decided to do was build a new computer, a 386, more powerful computer with a lot more memory chips in it, take that up to the telescope and plug it in on top of the old one. And if they can do that, then the computer will have a lot more memory than it did before, and it'll do a better job of computing and will send pictures back to the Earth more clearly and more quickly than the computer that's damaged.
How much of some of the work that the astronauts are doing is routine maintenance, that like they have to come back every few years and, you know, exchange things like batteries in your Walkman? How much of it is routine?
Most of it. The instrument that's being added tonight is not routine maintenance, but replacing the wide field and planetary camera was expected, because when they started manufacturing the camera, they had a certain amount of technology. The camera itself is a TV camera. It's not like a photographic camera. And the detectors on TV cameras that were available 5 years ago were not as good as detectors available now. So they knew they were going to have to put the new 1990s era TV cameras in that instrument. So they were going to do that anyway, and what they also added was a corrective lens to make up for the problem in the main lens. NASA commentator Kyle Herring is explaining what's happening in space. Let's listen.
Next steps in removing it from the protective enclosure to release the ground strap, which has been in place during its launch to orbit, and then release the latches before Kathy Thornton at the end of the arm pulls.
Houston, got enough TV in the cavity?
Story, we're happy with the TV.
Thanks, Greg.
Story Musgrave is asking the ground controllers if they've had enough television of the cavity where the new instrument is going to go. And as we were listening to commentator Kyle Herring just a moment ago, it appeared that he said that it was time to unhook the new instrument, the CoStar instrument, as it's called, the telephone booth-sized box that has the corrective lenses in it. This is a different view from the cargo bay of the Shuttle Endeavour, and it's a view of the protective container for the new CoStar instrument. You see the Hubble Space Telescope itself on the right with the sort of golden orange-colored light coming from it as a spotlight out in the cargo bay points at it. And as the picture from space changes and gets more clear, you can see it changes on your screen at home. But this replacement mission seems to be going well, well ahead of schedule. If the old instrument is out, and we haven't had that confirmed to us, but it sounds like it must be out because the astronauts are preparing to remove the new replacement instrument and put it into place. This is a good sign.
What can you tell us about the crew, about the two astronauts now out spacewalking?
Kathy Thornton is a long-time NASA astronaut, multiple college degrees, has been training for this mission in the underwater tank, has a degree in astrophysics. I'm impressed with anybody who can get through the college necessary to be a PhD in astrophysics. And in talking to Kathy, she can still speak English, which is amazing that these scientists who are so well educated can speak a language that you and I can understand. And she's one of those. Tom Akers is a fighter pilot. He's a man who's had a multiple faceted career. He was a high school principal for a while, and he also worked for the National Park Service as a park ranger. So it's
now he's up in space.
Yes, it's possible for park rangers to be astronauts too. What the astronauts are doing now, if you look in the center left edge of your TV screen, you can see, I believe it's astronaut Thornton, over the equipment box which contains the new corrective lenses. You see the circle around it there on your screen. And she will be opening that box and releasing a strap which holds the instrument in place. There's also an electrical ground strap there that connects the metal on the instrument with the metal on the telescope to prevent any sort of electrical damage occurring during launch. It's interesting, the shuttle, when it takes off, Bettina, goes through the atmosphere on Earth so rapidly that there's a possibility for static electricity buildup anywhere in it. I've been very surprised. I've been able to myself sit in a space shuttle. And when you do that, and in fact, back just before NASA returned to flight after the Challenger disaster, I was able to sit in a space shuttle trainer that the astronauts use, and the electrical system in there is remarkable. When you plug in your television, earpiece, and microphone, you immediately begin to get electrical shocks from the system. It's the electrical grounding is very important to all this equipment on board the shuttle.
How are the two astronauts linked to the shuttle itself? What kind of connectors, so to speak, do they have?
Kathy Thornton is connected to the robot arm. When she came out of the airlock more than an hour ago, she had some trouble. The first thing she did when she came out was hooked up a what they call a tether, which is a piece of wire connected to the outside of the shuttle. And that piece of wire got wrapped around her backpack, and she was unable with her hands to disconnect it. So Tom Akers had to come out of the airlock early and remove this piece of wire so that she could put her feet in place on the robot arm. So she's attached by her feet to the robot arm, and Akers is attached by a piece of metal, or metal wire, to the side of the shuttle cargo bay. As he moves around and clambers up the side of the Space Telescope, he will hook up another wire system to that. And so zooming in now on astronaut Thornton.
We figured it would have to wait till daylight.
As she's in this box, not exactly sure what she's doing with her left hand there, but let's listen and see if we can figure it out.
Clamp is clamped into the white material. Okay?
Okay, well, that's good news. That's nominal stuff.
Okay.
Turn down. Turn down. Good. Stop. Basically, I have the wrench on ratchet counterclockwise towards third base. Break it loose, man.
Okay. And sorry, the ground strap is off. Put my Essex wrench back up. Wasn't too bad, KT. The hard part was getting the wrench on.
You can hear the astronauts apparently grunting and groaning a little bit as they work in space with these instruments. Tom Akers just announced that the grounding strap, one of the things holding the new instrument in that box, had been removed successfully, and he said he was having a little trouble with his wrench. The reason they have so much trouble is that when you work on the ground, if you and I were to take a wrench and turn it, we would turn it and it would turn and nothing would be different. In space, when you turn the wrench with your hand, your body turns too. And it's just very difficult to make tools work unless you're firmly planted to something solid. So the astronauts have to always be sure they are touching the telescope, or else any work they attempt to do will be a failure.
You spoke earlier about that they trained for this mission in underwater tanks. How different is it to train underwater and then here in space?
It turned out, Story Musgrave talked about that on television earlier this evening, and he said that the tank training was certainly good training, but it was nothing like really what it is in space.
11, 13.
When the astronauts are calling out these numbers, it's because of wrenches or electric tools that they are using are expected to turn a certain number of turns before a bolt is released from the nut that holds it. And so they call out the numbers because the ground controllers will tell them if, for example, at 15 turns of this bolt, it's supposed to come loose, and if it hasn't come loose, then there's a problem. And they tell her whether to turn it one more time or two more times to get it loose.
So they must have big notebooks, so to speak, knowing how many turns each screw in this telescope has been turned. That's amazing.
Yes, and the ground controllers probably told her 5 or 10 minutes ago, maybe while we were on our break or we didn't have a picture from space, the next thing you turn, you'll have to have 15 turns or whatever on it. But yeah, the choreography of this mission is just phenomenal. Story Musgrave said that every time he was outside in the cargo bay, every move of his hands or feet he had practiced. And he wouldn't move his hands or feet in a way that he hadn't practiced unless there was some problem that he had to correct by doing something else.
Also, they must be so careful with the tools they use that they don't, for example, put cracks into their suits.
Yes, exactly. The spacesuits are 9 layers thick, and they have a lot of material to protect them there. But they are in the vacuum of space, and the temperature out there is more than 200 degrees below zero. So, exposure to the elements for an instant would be deadly. There you can see in Thornton's hand that wrench that she was using, counting the turns on. And to her right is this tool kit. It's a tool carrier. It looks sort of like the letter T, and it has a bunch of protuberances on it that you can attach tools to.
Next step will be to lift the CoStar package out of its protective enclosure in the cargo bay.
Power tool on 2, torque still 5.
This is good news, Bettina. Kyle Herring just confirmed what we thought we knew, which was that the old piece of equipment, that high-speed photometer, has been removed from the telescope, and the new instrument with the corrective lenses is now about to be lifted out of its protective container and taken up to the side of the telescope. At the point that it comes out of its protective enclosure, the tension will mount out there in the cargo bay, back in the shuttle crew compartment, and down on the ground at the Hubble Space Telescope Science Center in the control center, because that is a very delicate instrument. And just as we were discussing 24 hours ago, you take a delicate instrument out of its protection and you have to carry it through space, you got to be sure nothing bad happens to it, because if some damage were to occur during the next 45 minutes before it's firmly installed aboard the telescope, one of the major goals of this mission would have to go down in the failure column.
How is the mood at NASA?
They're getting happier every night, because at night after night after night, as things go better and better and better, they realize that they are winning. You see, the sun's coming up, and as it comes up, we'll be able to see clearer pictures, probably for the next 30, 45 minutes coming from space. And now you can see that instrument, the CoStar, right under the word Endeavour on your screen. That's what it looks like. Somebody operating the payload bay camera on the shuttle is trying, I think, to give us a better picture of it. You saw the camera bounce there. But there's a carrier on that Kathy Thornton will grab with her hands and just pull it straight up out of that box.
Stop. Hey, I'm in a good position to extract right here.
Okay.
So, Bettina, to our viewers, as I say, the next 30 to 45 minutes will be a critical period in the life of this Hubble Space Telescope repair mission. I'm going to walk across the aisle to bring our domestic viewers up to speed on what you and I have been able to show our international viewers live, and we'll continue our coverage here.
And John will be back.
That bumped my power switch to off. Okay, now we're really going to go. Here we go. It's coming loose. 1, 2, 3, 4, 5. I'm going to stop, KT. All right.
I can't make it move yet.
All right, that's 5. Let's go a few more. 6,
There it
7.
goes. Moving now.
Okay. 8, 9, 10, 11, 12. Torque limiter popped. Okay, how's it feel? Throw up any on it?
Yep, it's free.
Okay. I got an A-seated light story after about, no, it's 7 or 8 turns there when it came loose. Yeah.
Unfeathered story.
Thank you. Okay, let me come up and look at this B-latch now, KT. Safety tether looks good. Essex looks good. Put down in Slide it forward just a touch, KT, if you can. A little more. Yeah, I mean, look, I can't even see the B-latch. It went out of sight. Know how the little tapered part usually sticks out, Stuart?
And that concludes this part of our live coverage of the Hubble repair mission. World News is next, and we'll have more live coverage of the shuttle mission in the next hours. Thank you for joining us.
World News continues now with live pictures from the Space Shuttle Endeavour as astronauts continue their fourth spacewalk to repair the Hubble Space Telescope. Astronaut Kathy Thornton and Tom Akers are installing a device designed to allow Hubble's optical instruments to see straight, as it were. The device, called CoStar, is in a box the size of a telephone booth. You can see it right there. NASA scientists say it will take about 6 to 8 weeks before they can tell if Hubble's new equipment has corrected its eyesight.
Stop, and you don't want to get it going too fast so that you run into something before you can stop it. One of the tougher tasks for Kathy here will be the visibility. You can see that she has essentially a great big door right in front of her face. And she'll be getting up so that she can see the very top edge of the instrument as she puts it back into the side of the spacecraft to verify that clearance, while Tom will be down at the bottom helping guide it into the rails and watch that clearance and alignment.
And Tom Akers now climbing into that aft shroud area that they've opened up for this task. The two astronauts have just crossed 2 hours into the spacewalk.
Looking down at my safety tether, it looks okay.
Endeavour Houston, minute and a half to LOS. Be back with you on the west. 1954.
Okay, great. Much daylight we got left? Not much, Stuart? 42 minutes. Oh, Covey. All right.
How much?
42 minutes.
I'm going to turn my lights on anyway.
Okay, I think I still have one on. I took it off when we were doing the B-latch. Okay, KT, I'm just going to ease in here very gently.
And we'll bring you continued live coverage of the fourth spacewalk during this shuttle mission from time to time throughout the next hour here on CNN International.
They're just a few feet away from installing it in the telescope, and we don't yet have the live picture from there, but I am going to assume that we'll have live pictures so that ground managers will be able to watch this installation, and we'll be able to see it as well as this corrective optical instrument is plugged into the side of the Space Telescope. Joining us to offer commentary on this mission is an expert on the Space Telescope, what it's been able to do before and what it is going to be able to do if this instrument is installed correctly. Dr. Michael Shera from the Space Telescope Science Instrument. Doctor, what's going to be different with this instrument in place from what you astronomers were able to get from the telescope before?
CoStar is going to correct the vision of the ultraviolet camera, the FOC, the faint object camera, on the telescope, as well as the vision of the two spectrographs. With the UV camera, we're going to be able to do the most extremely high-resolution imaging that the telescope was designed to do, as well as take pictures in the ultraviolet. And with the two spectrographs, we're going to be able to do very detailed analyses both on star clusters, individual stars, and on galaxies to determine precisely what they're made of, what kinds of stars are in them, and how fast they're moving. Now, all the kinds of things that we haven't been able to do over the last 3 years.
Yeah, the faint object camera is one of those items provided to the Space Telescope by the European Space Agency, and as I understand it, because of this aberration in the main mirror, it hadn't been able to do very much work to this point at all. Am I right about that?
It's certainly been hobbled, and some of the things that we very much wanted to do with a faint object camera were not doable. But there have been some other images, some other projects tackled by the FOC that have yielded some really delightful surprises. And hopefully a little bit later on this evening we'll be able to take a look at some of the imagery that the FOC has produced in the past 3 years.
Speaking of delightful surprises, we now have live picture from the space shuttle that we can show you. Astronaut Kathy Thornton on your left with the CoStar replacement optics unit in her right hand. Her partner Tom Akers is on the right. He is called the free-floating astronaut. He's helped to guide that unit into the telescope. Let's listen to the NASA commentators in this final few minutes of the installation.
In other words, bring her feet up, but not her body. Okay, I'll pitch it up.
Claude Nicollier is operating the robot arm to which Thornton is attached.
So you may want to roll her left a little bit too. Give me a stable platform here. You follow, Claude? Put the PFR right over my legs. Okay, that feels good. You want to come back in, KT?
Yeah, bring me in about 3 inches, please.
Copy, Claude. Can't take her in 3 inches. Okay.
Stop.
Okay.
That's perfect, Claude.
And I stopped them. Taking our time. Okay.
We got lots of time.
Michael Chair, the astronauts being very careful as they do this job up in space. I wonder what your thoughts are. Does it look pretty good to you as far as the way things are going to this point?
It looks absolutely perfect. They're taking all the necessary precautions. They're still ahead on the timeline, and they really want to make sure that they don't jostle the instrument unnecessarily. They're doing exactly what they have to do at this point, and it's looking great.
Okay, we'll continue to listen as they go through the final few minutes of getting this thing plugged in. I suppose, Michael, while we listen, you could tell me, after it is seated in the right place, there are a lot of connections and hookups that have to be done too, right?
There are only 4 electrical connections and a ground strap. We certainly want to make sure that there's no buildup of static electricity on the instrument. The connections themselves and the strap may take as little as 15 or 20 minutes if everything goes smoothly. And with that in place, we'll have CoStar in, and we'll have all of our optically corrected elements in place.
Yeah. What are the electrical connections like? Are they like electrical plugs that you plug in, you know, the toaster at home?
A little more sophisticated than that. They do have to transmit information, so they're more like a modem that transmits data back and forth to and from a computer. The information gathered on the previous instrument, on the high-speed photometer, did have to be sent out to the computers, digitized, turned into the right zeros and ones, and then sent down to the ground. Here it's going to be a much simpler operation. We're basically going to move the arms with the optical elements into place. And those optical elements, once in place and once properly centered up, should only have to be moved very infrequently. So the whole CoStar box is going to be quite a passive device, just correcting the optics of the telescope.
And after this thing gets installed in the next hour or so, how long will it be before those arms extend those new mirrors?
That may be done very shortly. There really doesn't seem to be any reason to hold off, but I'm not certain what NASA's plans are at this point. I think that they're going to play it by ear and see how everything goes.
Okay, let's continue to listen as the astronauts talk and the final minutes of this installation of new optical systems for the Hubble Space Telescope.
I didn't torque it yet because I want to check it before I pop the torque limiter. I'm just at a hard stop. 6.5 is not quite enough, is it? Well, it's not supposed to be enough, but it's up 1.5 inches like the other one. The other one was a little higher. The other one was 2 inches up. Could be a little different dimension here, but let me look under here. B-latch is definitely seated story. Perfect, and the A-seated latch is out. Yeah, CoStar's longer than HSP. Okay. I thought the latch distance was going to be the same, but you want me to go ahead and pop the torque limiter here? All my indications are good. I'm up 1.5 inches off the rail.
As the astronauts continue their job of installing new optical instruments for the Space Telescope, we're going to take a quick break. We'll be right back and see how this mission is going. So far, so good, though, it appears right now. Stay with us.
That's affirmative story. Tom can take the torque.
Welcome back to our live coverage from Endeavour and CNN as 2 astronauts are out in the cargo bay right now. Kathy Thornton is about to grab Tom Akers by the legs so that he can get under the corrective optical box, phone booth-sized device, to make sure that the latches on that box are in the proper alignment out in space. This procedure to replace this box has taken the astronauts a little bit less time than expected. NASA has provided us with some animation speeding up the whole process so you can see what it looks like to have replaced this piece of equipment. There's what happened about 30 minutes ago as it came up out of a storage locker on the cargo bay. And this is what happened in the past 10 or 15 minutes as Kathy Thornton, on the robot arm operated by Claude Nicollier, pushed the box forward toward the telescope, with Tom Akers on the right there helping to guide it into place. And now as you look again at our live picture, Thornton is closest to the camera, still attached to the robot arm. This is a picture taken from a camera about halfway up the arm. Akers is in front of her. Let's listen to Kyle Herring, NASA's commentator.
She has a broken red stripe on the pant legs of her spacesuit. Tom Akers identified by the candy stripe design of stripe on his pantsuits.
I need to come up just a touch, KT. A little more, up.
The voice you're hearing now is Story Musgrave, the payload commander, who can see this same picture. He's using this picture to guide the astronauts as they install this piece of the telescope. KT, of course, is Kathy Thornton. That's what her colleagues call her.
P4 on J4 next. Okay, P4. P4 down here and up there. Big dog there.
Story Musgrave was interviewed on television several hours ago this evening. He said that he had been running scared since the very first day that he knew he was going to be working on this repair mission. And he's feeling pretty good tonight because it has gone as successfully as it has. But he also said that he's not going to be convinced it was a success till he sees those good in-focus pictures from the Space Telescope. Michael Shera is a scientist and astronomer who uses the telescope. I imagine you feel about the same way about this, don't you?
It's certainly going to be a nerve-wracking time until we get the first clear images back from the telescope. That should happen about 6 or 8 weeks from now. It's going to be necessary, first of all, to let the telescope outgas, let all the residual traces of atmosphere and contaminants from the shuttle escape from the telescope and from the instruments before we turn on all the high voltages. And then there's going to have to be a very careful set of focus tests that are going to have to be done on the telescope to ensure that we have the telescope focus just right. So probably sometime around the end of January, we should begin to be able to start taking real science images.
Now, 3.5 years ago, right after the telescope was launched in space, you ground-based scientists were attempting to focus the telescope, and that, I guess, is at the point when you found the spherical aberration problem with the main mirror.
That's right. We were able to get images that looked considerably better than those from the ground, but not anywhere nearly as clear as we had been expecting from space. Some optical scientists, both at NASA and at universities and at the Space Telescope Institute, started examining those images, and they were able to determine the spherical aberration problem rather quickly then.
That must have been a supreme disappointment.
It certainly was painful. And for a while, there was a great deal of gloom and doom, both around NASA, within the scientific community. But there
Michael,
were
let me
some
interrupt
images.
you for a minute. I hear some of the astronauts talking in pretty high voices right now. I want to hear what they're saying. Sure. Because they may be having a problem. Let's listen in.
While Tom Akers verifies all the connections at the bottom of the instrument, Kathy Thornton will be maneuvered by Claude Nicollier up to the top of the co-star to connect the top latch, the A latch.
That was Kyle Herring speaking for NASA, letting us know what's up.
Covers back in place.
They were talking in a loud voice because they were happy that the telescope replacement optical unit was where it was supposed to be. There's the power tool in Kathy Thornton's hand. She'll, as you just heard, go up to the top of this unit while Akers stays at the bottom, and she will latch the top latch, which NASA calls the A latch, while Akers handles the one at the bottom called the B latch. Makes a certain amount of sense. Michael Shera, we were talking about the disappointment that you and other astronomers at the Space Telescope Science Institute were feeling when you discovered the problem with the mirror. I know you were there just a few hours ago today. How are the scientists and astronomers feeling as you left to come down and help us with our coverage tonight?
Everybody's on a major high. My colleagues are just bouncing off the wall with excitement and with pleasure at everything that the astronauts have been doing. When CoStar was slipped in and bolted in last night, we knew that we had our imagery back, and we're now going to be able to answer all those big questions. How big is the universe? How old is it? Maybe even are there planets around nearby stars? All those things we were really frustrated in the last 3 years that we weren't able to do.
Yeah.
And tonight we're acquiring the rest of the power that the telescope was supposed to have. So this is just a glorious, exciting, wonderful time for all of us.
We'll watch as Kathy Thornton goes up to the top of the equipment compartment in the telescope. She'll be putting her wrench to work. You can see it's the shuttle is in sunlight, and those unusual images on the right of your screen are caused by sunlight hitting a camera lens that is providing us with those pictures from that angle. But I hope NASA will let us continue to see this picture anyway as Thornton gets her job of tightening the CoStar unit into place underway. How many new mirrors are there in this unit, Michael?
There are 10 mirrors in total inside CoStar. 5 of them are very passive. They simply redirect the beam, the incoming beam from the telescope, onto 5 other mirrors. And those 5 mirrors are very carefully polished, extremely difficult to produce, quarter-size mirrors that have essentially the opposite curvature that the mirror does, that the primary mirror does, and they correct for the aberrations in the telescope.
Based on this picture right now, where is the primary mirror in relationship to Kathy Thornton on the robot arm?
Above her. The the primary mirror actually sits above the instruments, so perhaps 6 or 8 feet above where she is now.
Yeah. And from where she is, there's no way she could touch that mirror, right?
Oh no, it's completely enclosed. One of the early plans for, or one of the early ideas bounced around was perhaps trying to go up and replace the primary mirror, but it's just too bulky, too massive. There was no way of doing that.
Mm-hmm. Let's listen to Kyle Herring at NASA again.
Into place. The CoStar is now securely in place in the telescope.
Okay, you're all done, Tom. We'll get some end effector video. Okay, so they're going to get some end effector video, KT.
The astronauts are going to change the camera that they use to a black and white camera that is directly below the feet of Kathy Thornton. So in a minute, the picture we see will change to a black and white picture, but it will be extremely close to the CoStar box. Right now you see the picture from the robot arm. You can see the wing of Endeavour at the top of your screen. And she's moving back now from the telescope. Michael, you were talking to some of your colleagues at the Science Institute, and they had detected a problem with the doors that were open tonight, as we had a similar problem with doors a couple of nights ago when the gyroscopes were replaced, right?
There was an attempt by the astronauts as soon as they opened the doors to see if they could quickly close them, and there did seem to be a bit of difficulty in reseating them, as there had been a couple of nights ago. We're just going to have to wait and see what happens here, but they certainly did succeed last time, and I'm confident that they will again.
Yeah. Right. Well, these astronauts are fairly resourceful. Story Musgrave, in this interview that I told you about that he did earlier tonight, talked about the fact that that was not something that was planned for. The fact the astronauts might not be able to, didn't expect to be able to have a problem like that come up, but they certainly were able to handle it then. We're going to take a break. We'll be back with more live coverage of the mission of Endeavour in just a minute. Stay with us. Welcome back to our live coverage of Endeavour. Let me show you a picture from space. It's a picture that we promised you a minute ago from a black and white TV camera that's exploring and moving slowly back and forth at the bottom of the robot arm, looking at the CoStar device that is designed to correct for the faulty vision in the Hubble Space Telescope's many of the units. And if it is successfully installed, and the ground-based managers are looking at these pictures right now to determine whether it is successfully installed, and it works well, then we're going to be able to see some remarkable pictures from space like never before. And according to the experts, including our guest here tonight, Michael Shara, the pictures will be just about as good as the Hubble was advertised as being able to produce more than 3.5 years ago when it was launched.
That's certainly true, and in some sense a little bit better. We've been hearing numbers like, oh, we'll get back 90 or 95% of the capabilities, but in some sense we're going to get back more capability because the WFPIC, the new wide field and planetary camera that was installed last night, has much more ultraviolet sensitivity than ever before, and a lot of the problems with the original charge couple device chips have now been corrected. So in some ways this telescope and the new cameras are going to give us even more capabilities, and we're really excited about that.
Yeah, Mike, we haven't talked yet about the device that was taken out of the telescope to make room for this, the high-speed photometer. What is it and what did it do?
The high-speed photometer is basically a light meter. It's a device that can look at a star, a point-like object, and measure how bright it is approximately every 10,000th of a second. There aren't many things in the universe that can change their brightness that quickly, but those that can are extremely interesting. For example, the accretion disks around black holes, neutron stars, or the near environs of white dwarfs. These are very, very dense collapsed objects, and the high-speed photometer was largely designed to look at the very, very close regions to these very interesting objects.
All right, as we continue to take a black and white camera, very close-up survey of the CoStar box, a box that we've described to you for a while as being about the size of a telephone booth. We're looking at the lower left-hand corner of the telephone booth now, and I would be willing to bet you that is a latch. It appears designed to be turned by an astronaut using a tool or a gloved hand. It appears there are several of them there. We can listen to the astronauts as they talk about these pictures as they're coming down live from Endeavour.
How's the end effector video going? It being done it's still about 2 or 3 minutes, I guess.
Okay, as the NASA managers on the ground continue to determine for themselves that the installation job was done well and done a little bit ahead of schedule, we're going to take another break. We'll be right back. Stay with us for live coverage from Endeavour and CNN. Welcome back. Two of Endeavour's astronauts, Kathy Thornton and Tom Akers, are outside in the cargo bay of the Shuttle Endeavour right now. They have just completed installing a set of corrective optical instruments for the Hubble Space Telescope. NASA managers on the ground have been looking at close-up pictures of the installation process. They seem very pleased with what is going on so far. The astronauts went out into space a little bit more than 2 hours ago, so they're operating well ahead of schedule. Actually, about 2.5 hours ago, they went outside. The next job for the astronauts is to replace or add to the Space Telescope's computer. It's a process that will take them, according to NASA managers, about an hour and a half to perform. They'll be going to get the computer inside the cargo bay and carry it up to the location where the current space shuttle computer is located, put the new one on top of the old one. That's a process that will double the memory capacity of the computer and will make the telescope be able to store more information at a time before it has to dump it back down to Earth. The new computer will work considerably faster than the old one as well if it's installed correctly. We're going to take a short break. We'll be back with more live coverage from the Endeavour, from space, and from CNN.
U.S. Space Shuttle astronauts reach new heights as they try to fix the fuzzy Hubble telescope.
From CNN International, this is World News with Bettina Lucia at the CNN Center.
Hello and welcome to World News. U.S. Space Shuttle astronauts are well into their fourth spacewalk to repair the Hubble Space Telescope. Astronauts Kathy Thornton and Tom Akers are installing a device called CoStar, which is designed to allow Hubble's optical instruments to see straight. The astronauts have already removed a phone booth-sized instrument to make room for CoStar, and CNN International will bring you extended live coverage of the Hubble repair mission in about 15 minutes.
Hi.
Hi.
I was wondering if it was possible to see any of the previous pictures from the Hubble telescope.
Well, you know, the Hubble telescope has made so many beautiful pictures of the universe. We at CNN have tried at the time that they are released to people like us to share them with you. Michael Shera has brought some along with him. He can show you some of those now, I think. Michael, go ahead.
Sure. If we can show the first graphic, please. What we have here, this is actually a ground-based picture, and I'm going to go to the next one in a couple of minutes. This is a ground-based picture of a comet that swung by Jupiter last summer. This is Comet Shoemaker-Levy number 9. And this comet, which is basically a big hunk of ice, got smashed by the tidal forces of Jupiter. If you look towards the center of the image, you see a bright region, and that's the center of the comet, which has been broken up into several pieces, but it's really difficult to discern what's going on. If we can go to the next graphic, please. This is a Hubble Space Telescope picture view of the same area, and those bright individual condensations are pieces of the comet, pieces of the glacier, which is really the nucleus of the comet, that have broken up. Every one of those individual pieces is probably 2 or 3 miles across. Moving at up to 40 miles per second, they're going to go smashing into the atmosphere of Jupiter next July. When that happens, there's going to be the equivalent of many, many millions of megatons of explosive released in the atmosphere of Jupiter. It should be one of the most violent events that's happened really in centuries within the solar system. Now, unfortunately, those pieces of the comet are going to go smashing onto the backside of Jupiter, so we're not going to be able to see it directly. But Jupiter spins on its axis every 10 hours or so, and so the remnants of the explosion should be visible in just a few hours to us. Furthermore, the light emitted by all of those fragments crashing down onto Jupiter should be seen, at least indirectly, by reflected light off of the moons of Jupiter. So we expect to be focused in either on Jupiter or on one of the moons as this colossal traffic accident occurs.
When is it going to occur, Michael? How?
Next July, July the 20th approximately.
All right, and people on the ground, would we be able to see anything of this at all?
Certainly, if you look up at Jupiter, there should be lots of extra light. The moons of Jupiter may get much, much brighter. One of the reasons for the picture that I just showed you, for taking the picture with the Hubble Space Telescope, was to try to ascertain how big those pieces are. Of course, the bigger they are, the more kinetic energy they have when they smash into Jupiter. And so astronomers have been trying to estimate or guesstimate how much energy is going to be loosed in the atmosphere of Jupiter and what the effects on the atmosphere of Jupiter will be. It may be that all the cloud patterns on Jupiter will change dramatically, so even with a small telescope, we may be able to see some very dramatic changes even from the Earth.
Now, as the Hubble takes a picture of Jupiter, how long will it be from the time that picture is taken to the time that you all at the Telescope Science Institute would share it with us?
Some of the data will be released essentially instantaneously. This is such an extraordinary event that we want the public to be able to see it and to share the excitement with us.
So at the end of July, you and I should get together in Baltimore and look at some beautiful pictures together.
With pleasure.
All right, we'll do that. We're going to take a break right now. We'll be right back with you. Call us if you want. We'll add you to our conversation. Hi, welcome back to our live coverage of the mission of Space Shuttle Endeavour. Let's take you quickly to space to show you what's happening inside the cargo bay of the Space Shuttle. We're having a picture that comes and goes every 5 or 6 seconds, and as soon as we get some new live pictures, we'll show them to you. We've been able to see during the break that the astronauts, Kathy Thornton and Tom Akers, have taken the high-speed photometer, the astronomical instrument that was in the telescope. They're now holding it up above the equipment box. You can see that now. Well, every time we say you can see it, it goes away. At any rate, they have this telephone booth-sized piece of equipment, and it's right above its storage compartment. It's being lowered inch by inch down into that compartment now, and it's been very interesting for the past minute or so. The pictures come up for about 2 seconds, and then it's gone away. We'll continue to take your phone calls, and we'll also be joined by someone, if you've been watching our coverage for the past few days, you're familiar with, Ed Weiler, the program scientist for the Hubble Space Telescope, who has been watching with us from his post at the Johnson Space Center in Houston. You can see the problems we have. The picture will be there for a second, and then it will go away. It's not a normal thing for this to happen, probably a communication glitch of some kind, but there's the high-speed photometer in Kathy Thornton's hands, and as I say, the picture is very, very intermittent here. But the mission for tonight was to take that piece of equipment, the high-speed photometer, out of the Space Telescope. It was done very effectively in the early moments of the spacewalk last night and this morning, Eastern Time, and to store it temporarily out on the shuttle's wing. And we're going to have a live picture, and you can see there what it looks like, the telephone booth-sized box in Thornton's hands. and then to replace it with a new piece of equipment that has newly ground mirrors designed to clear up the out-of-focus problem with all the other instruments aboard the Space Telescope. The pictures from space continue to be dramatic and good. The shuttle is flying in darkness now over the Gulf of Mexico. It passed over Florida about 5 minutes ago. It'll be in sunlight soon. We'll have some other pictures so you can see more clearly with the sunlight beaming down into the cargo bay. We're going to take a break. We'll be right back. Stay with us. Welcome back. Live picture from Endeavour as Kathy Thornton lowers the high-speed photometer device into a carrier on board the Space Shuttle Endeavour. You can see it's going down into the box. They're having to woman handle it a little bit to get it to make a smooth descent into that box. Thornton's in the center of your screen, attached to the robot arm. Tom Akers is to her right, just the right corner of your screen. Let's listen in as they try to get this part to fit into its container.
Clearance on the aft fixture. Check. There's about 1 foot check there. Negative orbital roll, KT. Bring your side down and the starboard side up.
But I don't see the guide rail.
Well, let's just stabilize. You get in position where you can, okay? I've got it.
I'm trying for it, Clark.
Okay, I got it forward much more because of the... Okay.
All right, as we watch the astronauts work, let's bring in our colleague Ed Weiler, the Hubble program scientist from the Johnson Space Center in Texas. Ed, you've been with us 3 mornings in a row, and every time we've asked you whether this is a big success or not, you say basically, not till the fat lady sings. Has the fat lady sung for you yet?
No, I think she'll sing in about, well, first we have to get the astronauts down safely, and then we've got to make sure these new optical instruments are fully functional, which still will take about 6 to 8 weeks.
Yeah, yeah. What have you heard down there about the electrical tests on the replacement optical instruments that were installed about an hour ago?
Okay, well, so far all we've done is an aliveness test, which is similar to, you know, if you think of buying a brand new car and you turn the key halfway and the lights come on and the radio works. We haven't turned the ignition on yet. And that comes at about 8 o'clock this morning when we do a functional test where we actually drive out the little arms that have the mirrors on them about 1 inch just to make sure the motors are working.
Yeah, I don't know if our producer let you know, Michael Shara from the Space Telescope Science Institute is here with us in Atlanta, helping us with our commentary. The sun's coming up under Endeavour now. You can see the bright light as sunlight begins to hit the astronauts as they work there in the cargo bay. Michael was telling us earlier that as an astronomer who works on the telescope a great deal of the time, he's feeling pretty comfortable about things. But I guess you always have to be cautious, don't you, Ed, before you know that that this stuff is working properly.
Well, I can appreciate Mike's elation. However, I'd encourage him and all other astronomers not to declare victory until we achieve victory.
I hear you, Ed. Nevertheless, I think I can hear the fat lady humming.
Okay. I hear her breathing.
This is... Ed, could it have gone any better than it's gone so far? From
Absolutely not. I think the real story here is, you know, what the astronauts have done, how the training has paid off. It's just incredible. If you'd asked me 2 weeks ago, would we be sitting here on EVA day 4 and we would go through? I used to say we have this one-page plan that shows the outline of the EVAs, but we have 3 feet of contingency plans.
Yeah.
We're still on that one page.
Mm-hmm. It really is remarkable, isn't it? I mean, there's so many things that could go wrong when you're out there in the cargo bay. And as you pointed out, you had a 3-foot thick stack of papers with what to do when thing A, B, C, D, or whatever went wrong, and it just hadn't happened that much.
That's right. I think we've had basically 2 anomalies, both of which we can handle. The first one was the doors that wouldn't close on the first night, which wasn't that 3-foot stack, and it was an easy fix. And the other one was a small problem with some insulation on the magnetometers last night, which we'll take care of tomorrow. Yeah, Story Musgrave said in a TV interview earlier tonight that he's been running scared since the beginning of this mission, but his fears certainly haven't been too justified, it seems to me. Sure, I think we all have been, and we're getting a little less scared each night.
Yeah. What's left to do?
Well, tonight, I don't know if you've got a live picture now, but the next thing to do is to put on the so-called coprocessor, which is a bunch of extra memory boards. It's equivalent to upgrading your computer at home with more memory. It's one of our lower priority tasks, second priority task, but it fits in well tonight. And then tomorrow we've only got a half an EVA schedule, a couple hours, and to put in the so-called solar array drive electronics box, which is a box that failed We have 2 of them, luckily, so this is just bringing us up back to full redundancy. And that's the electronics box that controls the motion of the solar arrays. That is to turn them around to always face the sun.
Ed, are you watching the live picture now from NASA?
No, I do not have it on.
Okay, something very strange just appeared on my TV screen. It appeared that it was like a smoke ring almost from a cigarette that came up out of the base of the cargo bay and moved right past the camera that is on the elbow with the robot arm. I have no idea what it was. It might have just been some sort of optical illusion, but...
there may have been a loose strap floating around that just temporarily passed in front of our field of view. I think that's what it was.
Yeah, it was an interesting sight in this mission that seems to be going so well. Anytime you see anything that's extraordinary, I think you need to stop and comment on it. We have a lot of viewers who'd like to join our conversation. Our first caller's from Kentucky. Go ahead. You're on CNN.
Yes, my name is Timothy Bailey, and I would like to ask first, is there any plans to utilize the data gathered from Hubble to augment information coming in for radio astronomy? And also, will using data gathered from other probes like the SolarMax studying our own star, can we use this data to help locate stars in this galaxy that are possibly near enough to our star to support a planetary system?
Ed or Michael, either one, jump in.
Well, I think you brought up a very good point, because it gets lost when there's all this TV coverage of Hubble. I mean, astronomy is a process. It's like any other science. Take medicine, for instance. A doctor doesn't do a diagnosis with just a stethoscope. He or she uses a whole range of instruments, and that's exactly what astronomy is all about, too. Hubble will do a lot of unique things and will answer a lot of fundamental questions. But some of the most fundamental questions in the universe, like is it open or closed, will it contract someday, those are kind of questions that are going to take a lot of research with the combination of Hubble, X-ray telescopes in space, gamma-ray telescopes in space, the large new ground-based telescopes, including radio telescopes and the large new radio array that was just put into action, the very long baseline array. These things... this is just the way astronomy is done. Mike, you want to address the solar thing?
Certainly. Well, there's no astronomer who would dream of attacking just one small branch of the field or ignore most of the electromagnetic spectrum and just use, for example, the Hubble Space Telescope. We do need other telescopes, and all the telescopes, both on the ground and in space, working together, as Ed said, work together as a team. One of the few things that the Hubble Space Telescope can't look at is the sun because of its tremendous brightness. But by studying the sun, both with the SolarMax satellite and with ground-based telescopes, we get a very clear and very detailed picture about what a typical run-of-the-mill garden variety star is like. And since we know that there are planets orbiting this kind of star, we can then use the Hubble telescope to look at other stars, which have been located with other telescopes, that are similar to our sun, that have the same sort of spectral characteristics. And over the next year or two, it's certain that astronomers will be using Hubble to look at very sun-like stars. Astronomers call them G dwarf stars, to see if there are things that might possibly be planets around them.
To bring you up to speed on what's going on in space right now, Kathy Thornton is closing some latches which are holding the high-speed photometer instrument in place in its cabin in the cargo bay. And very shortly we'll probably see the top on that container come down. We'll continue to provide live coverage with that as we continue to take your phone calls. We're going to take a break right now. We'll be right back with some more phone calls from around the country. Stay with us. Welcome back to our live coverage from the Space Shuttle Endeavour. Joining us on the telephone from the Johnson Space Center in Houston, Hubble program scientist Ed Weiler. Here in the studio in Washington, Michael Schara from the Space Telescope Science Institute in Baltimore. I'm John Holliman. I'm along with you. And we have viewers on the line from several points in the United States. If you'd like to call in from another country other than the United States, let me give you the number to call, 404-688-1310 or 404-688-1306. Those numbers only if you're calling from a country other than the United States. Our U.S. viewers are stacked up several deep right now. Our next caller, I believe, is from Georgia. Go ahead. You're on CNN.
Yes, I was wondering what the approximate cost is to launch the space shuttle and what are the requirements for a person to become an astronaut.
Ed Weiler, what did it cost to launch this mission to repair the Hubble Space Telescope?
A typical shuttle launch is between $300 to $400 million. And what does it take to become an astronaut? That's a tough question. We have astronauts who are military pilots. We have astronauts who are astronomers, who are doctors, medical doctors, who are biologists. Basically, it takes a lot of education, and or to be, well, I shouldn't say that, or you're a military pilot, and obviously a lot of military pilots have a lot of education too. But you have two paths really through the military, through the pilot program, or through just a normal path where you get a good education, a technical degree, and apply to the astronaut program.
Yeah, basically it amounts to, if you want to drive the spaceship, all of the drivers, the pilots and the commanders, generally come from the military, and if you want to ride in the back and do the work, you come through the scientific community in general.
That's exactly correct, yeah.
Okay, the picture we're seeing live from space now is Kathy Thornton on the end of the robot arm. She's opened up a compartment, and I'm not sure I believe this is a compartment where the computer may be located. We can listen to NASA for a minute and see if we can get brought up to speed on exactly what Kathy's doing here.
Okay, go ahead, drive it in.
Steve Brown, and KT, I'm going to go look, store.
Relax.
Get there, she can hold it forward and then swing far enough aft to watch me go in the hole. That's what we ought to do. And she can't hear me, of course. KT, do you want to swing aft and watch the bee while I drive it?
Clear.
Like we used to.
It's not going to go anywhere now. It's up on the ASA.
Well, we want to watch it go in, okay?
Right, Claude, could you roll me to my right a bunch?
Roll to your right, okay?
The ballet performed by these astronauts as they work together to do any job is just remarkable. You see Kathy Thornton there with her power tool. She needs to be in a certain position to find a bolt to turn it 3 turns with a wrench, and she's getting a great deal of help from Claude Nicollier, who's operating the robot arm, which moves her hand into position to find the bolt with the wrench. Nicollier is back inside the crew cabin of the shuttle. He has, in addition to 2 windows, 2 at least TV monitors, one of which is showing him the same picture that you and I are looking at right now, so that he can see where that wrench is, and he can't see where the bolt is from that position. But he's using the same picture that we are to help guide the robot arm to help Kathy Thornton do her job. Our next caller, by the way, with a question is from Texas. Go ahead. You're on CNN.
Yes, good evening. My name is Rich Gargis, Louisville, Texas. I was wondering, after reading an article in either Sky Telescope or Astronomy Magazine, about an article on Ober's light. And the article said that if the universe were infinite, that we would have a white sky at night as opposed to a black sky. However, in another feature, there was an Anglo-Chilean telescope, I believe, did a deep exposure of a CCD image device, and got an image of galaxies overlaying galaxies overlaying galaxies. My question is it possible that part of the 2-degree Kelvin background radiation we see is in fact Ober's light? And if it is, will Hubble telescope be used to research that?
Ed Weiler.
Thank you.
Well, actually what they're referring to is Ober's paradox, and that was a popular thing back in the days when they were talking about a steady-state universe, that is one that doesn't change, is uniform in all directions, or an open or a expanding universe, the Big Bang Theory. And it's very simple, actually, if you think about it. If you had a steady-state universe where the number of galaxies, if you look out twice as far, you see 4 times as many galaxies. If you look out 3 times as far, you see 9 times as many galaxies. Basically, you're looking at the surface area of a sphere, and the number of galaxies increases by the square of the distance. If it were a steady-state universe like that, no matter what direction you looked at, you'd always be seeing at some distance the surface of a galaxy. And the further you looked out, you'd see more and more galaxies. Basically, if that were the case, if we lived in a steady-state universe, according to Olber's paradox, the sky would be white because it would just be covered with galaxies. And of course, it's not, it's black. So that's why we feel we're in an expanding universe.
Our next caller is from Paris, France. Go ahead, you're on CNN.
Hello, yes. I'm calling because I would like to know what's the contribution of the European Space Agency in the telescope.
Sure. That's Basically, the Hubble Space Telescope is a cooperative project between NASA, the National Aeronautics and Space Administration, and ESA, the European Space Agency. And ESA is comprised of 13 countries, including France, of course. ESA is about a 15% partner, and their contribution included the solar arrays that you saw put on perhaps this week, and also the faint object camera, which is one of the instruments within the Space Telescope. We have a wide field camera, sort of like a wide-angle lens, versus the faint object camera, the European camera, which is, you can think of as a zoom lens. The other contribution is they supply about 15 scientists and engineers as operators and scientists, basically, at the Space Telescope Science Institute in Baltimore.
Could you comment about the success of the ESA programs as opposed to the failures in the NASA program, specifically the Galileo spacecraft and the Mars Observer?
Well, I think you have to take things, in perspective. I believe in the last 5 years, we've had two outright failures: Mars Observer and a NOAA satellite, a weather satellite, and 3 partial problems. Certainly Galileo, we're not sure that's totally a loss yet. We don't think it is, at least. Hubble certainly wasn't a total loss, as you're seeing on television now. And another one which I can't think of. So you had 2 failures, 3 problem children. Those 5 items are out of, over that 5 years, 55 successful launches. So I think you have to take it in perspective. I think the failures get a lot of attention, but I think people forget about the other 50 or so successes over the last 5 years. And that's not even talking about things like Viking or Voyager or Apollo, et cetera, et cetera.
All right, what's going on in space right now is that Kathy Thornton is getting out a new computer that's going to be attached to the current computer aboard the Space Telescope. As she prepares to get that computer out of its equipment container, we're going to take a quick break. We'd like to hear from you. Call us if you like, and we'll be glad to take your questions. We have a lot of experts here to help us answer them. Stay with CNN.
So you've got the filter installed, and you have it at -2.
Welcome back to CNN's live coverage on CNN and CNN International of the repair mission for the Hubble Space Telescope. Kathy Thornton down in an equipment box. She has opened a box which contains a new co-processor for the main computer aboard the Hubble Space Telescope. Michael, I want to ask you what that computer does. Remind me to do it in a minute, but we've had some callers who've been on the phone for a long, long time now, including a caller from Texas. What's your question?
Well, actually, I'm from North Carolina.
Sorry, go ahead.
All right. Ace O'Connell of Wilmington, North Carolina. I have 2 quick questions. But first, Mr. Holliman, would you... my wife wants to go to bed so bad. We've been watching this for 3 nights. But Twyla, my wife, wants to know why the spacewalkers can go 7 hours without a bathroom break.
They don't. They're...
No.
Sorry,
Gail, this is something that I asked the question of the manufacturer of the spacesuit the other day. They don't have to do that. There are 2 systems in that spacesuit to help them urinate. They can wear a diaper, which some of them do, and there's a cup-like device in there that they can use, which will protect them for the need to urinate. But the astronauts tell me that when they're in those spacesuits, they don't generally have to do it, even though they're up there for 7 hours. The reason is that the humidity inside the spacesuit is very, very low. And it turns out in conditions of very low humidity, you don't have to go to the bathroom as much as you do if you're in normal humidity like we are on Earth. Our next caller is from Florida. Go ahead. You're on CNN.
Hi, my name is Manu. I'm calling from Clearwater, Florida. And I was basically wondering how do you name these telescopes? I mean, why is Hubble called Hubble, or for that matter, why is Endeavour called Endeavour,
Endeavour was named in a contest where school children submitted names and ideas. Hubble was named for a very famous astronomer who came up with the theory that the universe is expanding many, many years ago. And this telescope, it is thought, will confirm that theory and provide us with something called the Hubble constant, which is the rate at which the universe is expanding, maybe. And because of that, they thought it would be good to name the telescope for that fellow. Okay.
By the way, that's a very controversial number, and certainly one of the areas that the Hubble telescope stands to make some real progress. There are 2 schools of thought as to the rate of expansion and the rate of slowing down of the expansion of the universe. One of the ways that we hope to be able to determine that number more accurately is by using the corrected telescope to look at galaxies at intermediate distances and find variable stars in them. Those variable stars can be used as a sort of standard candle, a kind of 100-watt light bulb. And by using those essentially known objects of known luminosity, we can determine how far away the galaxies are and then determine how fast the universe is slowing down in its expansion.
Our next caller is from Ontario. Go ahead, you're on CNN.
Yeah, hi, my name is Larry. I was wondering if you could tell me what the temperature is up there.
A couple hundred degrees below zero. Ed Weiler, do you have a pretty good temperature number for what the temperature is out there in the cargo bay right now?
Well, in the cargo bay, what the sun's shining like is right now, I'm watching it finally. I found it here on my monitor. It's probably running somewhere 100 to 200 degrees Fahrenheit.
So it's very hot when it's hot and in the sunlight, and when it's in the darkness, it's about minus 200?
That's minus 100 to 200, yeah. It depends if the Earth is if you're looking at the Earth, you get infrared radiation off the Earth, which keeps it a little warmer at night.
It's a good thing the spacesuits are as thick as they are, I think.
That's right.
We're going to take a break. We'll be right back with more phone calls from you and more live coverage from the Endeavour astronauts. Stay with us. Remarkable picture from 360 miles above the Earth. Kathy Thornton on the shuttle's robot arm. She's spinning herself around, looking at her toolkit there now, preparing for the next part of this mission, replacing a computer or adding to a computer on board the Hubble Space Telescope to give it a lot more memory and allow it to do computations a lot faster than it has been able to in the past. We have phone calls and experts to take your calls. Our first call is from California. Go ahead. You're on CNN.
Yes, I wondered what the apparent resolution of the Hubble telescope is relative to, say, the Mars observer. You know, if the telescope was looking at Mars, what would be the relative resolution?
Michael?
Well, if the Mars observer were working, it certainly would be able to see much, much finer detail. The Mars observer, though, would be in orbit just a few hundred miles at most above the surface of Mars. That's, in fact, why we send interplanetary probes and why NASA works so hard to send out interplanetary probes, because when you get that close into a planet just a few hundred miles away, the Space Telescope can't compete. On the other hand, it costs a fair fraction of a space telescope to send out a Mars observer, and the Space Telescope is an all-purpose observatory. The resolution of Space Telescope, once all of the optics are corrected, is going to be better than 1/10 of an arc-second on any image, any time. With the Mars observer, we would have been doing, perhaps 100 times better, maybe even 1,000 times better with the highest resolution imagery, but only on that one target. With Space Telescope, of course, we can point anywhere in the universe, any planet in the solar system, any star in our galaxy, any galaxy in the universe, and achieve much, much higher resolution than we possibly could from the ground.
Okay, we've got time for a 1-minute quick call, also from California. Go ahead, you're on CNN.
Hello?
Hi, go ahead.
Yeah, my name is Bob Baroni, and I'm calling from California. I have two questions. First of all, if we're about other stars in our universe that resemble our sun, are the composition of those stars similar or identical to our sun?
The answer to that question is that there are stars very much like the sun in temperature and mass, which have about the same composition as the sun, virtually identical in some cases, and others which are very much like the sun, again in temperature and mass, but which have far fewer heavy elements. Everything heavier than helium is referred to collectively by astronomers as metals. And it's believed that those stars are significantly older than the sun, that they were born much before the sun and long before the galaxy had a chance to enrich itself in heavy elements. Modern theories of astrophysics supported by observations, some of which are now coming in from the Hubble telescope, indicate to us that the entire Milky Way galaxy and probably all other galaxies were born just with stars made of hydrogen and helium, and those first generation stars, some of them evolved and exploded as supernovas and spewed out a lot of heavy elements into the cosmos. Those heavier elements, everything from lithium on up to uranium, were then absorbed into clouds of gas and dust, which then condensed into subsequent generations of stars. And our sun is probably a second, third, or fourth generation star in the Milky Way. So the heavy elements in its atmosphere have been produced by other stars.
Michael, thanks very much. We're going to take a quick break. We'll be back with more coverage live from Endeavour and CNN. Stay with us.
More than 300 miles above the Earth, Phase 4 of the Hubble repair mission. If all goes as planned, the telescope should now be optically correct.
This is CNN's Worldwide Update. News without borders.
Hello to our viewers around the world. I'm Brian Christie at the CNN Center in Atlanta. Thanks a lot for joining us. We will get to our other stories moments from now. But first, let us go to space, where astronauts seem well on their way to completing another flawless repair on the Hubble telescope. CNN's John Holliman has been following the mission since it began. He joins us now with the latest. John?
Brian, the astronauts wanted to spend 2 nights in space doing spacewalks to clear up the out-of-focus vision of the Hubble Space Telescope, and they've done everything they were supposed to do that now. Last night, they replaced the wide-field and planetary camera, the main camera in the telescope, and tonight they have put in a set of corrective lenses, 10 actually finely ground lens mirrors that are reflecting light, or will be reflecting light after about 7 o'clock Eastern Time this morning inside the telescope, to provide corrected video to all the other instruments aboard the Hubble Space Telescope so that it'll be able to see clearly, according to scientists on the ground, for the first time in its 3.5-year life. The mission has been very, very good. This is a picture of opening the doors in the side of the telescope for the removal of an instrument called the high-speed photometer. It is the size of a phone booth. It has it's actually a light meter. It measures light from distant objects in the sky, although without the corrective lenses in place, it wasn't able to do that as well as it might have. And it's now stowed in the cargo bay. In that hole was plugged the new set of corrective optics, and that operation went well. Electrical tests have been performed, and as I say, about 5 hours from right now, ground-based scientists at the Space Telescope Operations Center will send a signal up to the Hubble Space Telescope, and mirrors will begin to come down out of a hole in the side of it, which will be able to reflect light properly to the instruments inside for the first time. So everything's going well. Right now, the astronauts are preparing to replace a computer on board. Should take about an hour and a half. Brian?
Welcome back to CNN and our live coverage of the Hubble Repair Telescope mission. And John Holliman is standing by with the latest on Spacewalk number 4. John, NASA seems cautiously happy, cautiously pleased so far, I would think.
I think they must be very pleased, Brian. I'll tell you, Ed Weiler, who was on the phone with us from the Johnson Space Center 3.5 years ago when the telescope was first launched, was like all of the astronomers and the scientists at NASA. This is going to be the best thing that ever happened since Galileo looked up at the heavens for the first time. Nobody knew the main mirror in the telescope was not going to be ground correctly. So when the first fuzzy pictures came back, all of these guys had egg on their face. But they are pretty well convinced in their heart of hearts that this repair job is going to fix it. And, but they just don't want to appear too optimistic until the corrective optics have been shown with light from stars out in the heavens to do the repair job. And we have one of the astronomers who has used the Hubble Space Telescope in the past and continues to use it every day with us. Michael Shera is from the Space Telescope Science Institute near Baltimore. Michael, as you've watched the repair mission come together tonight, what are your thoughts?
It's a really fantastic job that the astronauts are doing. It looks like COSTAR is successfully in place. That repairs for us the faint object camera, the ultraviolet camera, the zoom lens on the telescope. The 2 spectrographs are going to be able to work with COSTAR in place, so we can do the speedometry on the stars that we want to do, measure their chemical compositions and abundances. And the wide field planetary camera got put in yesterday. The aliveness test was passed with flying colors. And so if everything keeps on going the way it has been going, we're going to have a fully functional telescope when the astronauts leave it behind.
We urge you to join us in our conversation. We have a caller now on the line from Alberta, Canada. Go ahead, Alberta.
Yes, my name is Peter Hebert. I'm in Edmonton. Thank you for this opportunity to participate. I appreciate it. And my question is, will Hubble be able to see the Oort cloud of comets?
That's a difficult question, and we're certainly going to try. There have been requests that have come in to the Space Telescope Institute by astronomers to try and image the Oort cloud. The Oort cloud is a hypothetical group of comets, many, many millions of comets, that should circle mostly in the outer environs of the solar system, and they're basically the debris left over from the formation of the solar system. We don't know how many of these things exist out there. We don't know how big they are. We would certainly like to confirm their existence. One of the things we can do with the telescope is take very, very deep pictures to pick out these very, very faint things by pointing in almost any direction in the sky. The comets, which are really just big icebergs floating around, should appear as tiny little streaks, whereas the distant background galaxies and stars will either be little smudges for the galaxies and little points of light for the stars, so we can differentiate one from the other.
Space Shuttle right now is over Western Australia. It'll come back into range of a tracking and data relay satellite so that we can see live pictures from space momentarily. For right now, we're showing you some pictures on tape made just a few minutes ago when we were able to have communication from space showing the astronauts at work. Our next phone caller is from New Jersey. Go ahead.
Yes, hi. They're doing a great job on the Hubble, but my one question is regarding why aren't they doing it during the day for all the school systems to take in this beautiful coverage you're doing and using it as a learning experience and taking advantage of all this technology?
Because they couldn't. And the reason they couldn't is because the Space Shuttle has engines and solid rocket motors that can only get it to a certain place in the sky. And what they had to do was launch the shuttle from Cape Canaveral in Florida at a time that the Hubble Space Telescope was almost directly overhead. And because if the telescope and the shuttle weren't close together right after launch, the shuttle would never have been able to catch it. And the only time during the month of December that it was directly over Florida was at 4:30 in the morning the first day they tried, and then, or 4 o'clock in the morning the first day they tried, and then 3:30 in the morning the second day they tried. It's something called orbital mechanics that I don't understand completely, but I did ask the same question you did. If they'd waited a month, they could have done it in daylight, but it was too expensive to keep all these instruments that are going on to the telescope to replace it in storage in a clean room on the Earth, which costs, I'm told, about $1 million a month. So to save $1 million, they did it in the middle of the night.
And it's certainly true that we regret it. We would deeply have enjoyed sharing all these pictures during the day with school children. There are replays during the day, but unfortunately the orbital mechanics really did dictate that this had to be done at these very, very difficult hours.
Well, as we continue to wait for live picture to come back down from the Endeavour crew high above the Earth in daylight now over central Australia in the few minutes we've been talking, we're going to go back for other news because there is a lot of other news going on in the world right now. My colleague Brian Christie standing by with some more of that. Stay with us. It's going to go out about 3 hours instead of the 6 hours that previous spacewalks have been planned for, Brian. Just a few minor improvements to the Hubble Space Telescope, things that the telescope could continue to operate without, quite frankly. But the astronauts had the time. The mission was planned for enough time for them to do all of these bits of work. There's going to be one additional bit of repair work to a project that they replaced. You'll remember about this time last night, the astronauts replaced a couple of magnetometers up at the top of the telescope. There's a problem that was discovered with the old magnetometers that the astronauts are going to go up tomorrow night and compensate for. They're going to put some extra insulation around the electronics boxes for the new magnetometers to keep those pieces of equipment in good shape. So that's what's going to happen tomorrow night. And there's one more thing to do tonight. I'll tell you what the current progress of the mission for the night is. Astronaut Kathy Thornton has a new computer co-processor for the Space Telescope computer. She's out at the end of the robot arm with that right now. She's being steered by Swiss astronaut Claude Nicollier over to the point where this new computer will plug in to the top of the old one. And then there'll be some very delicate hand work for the astronauts in these very thick, oversized gloves, as computer connectors on the side of the old computer will have to be unplugged and then plugged into the side of the new computer. We'll be back with more coverage at the top of the hour. Sports Late Night coming up next.
And welcome back to our continuous live coverage of the U.S. Space Shuttle mission with Endeavour, trying to repair the U.S. Space Telescope Hubble. With me here again is CNN's John Holliman. John, how's it been going the last few hours?
Very, very well, Bettina. We could, I think, show you some live pictures from space as the astronauts conduct the last important thing they have to do on this scheduled 6-hour spacewalk. What you see there, astronauts Kathy Thornton and Tom Akers, they're over at the side of the Space Telescope. They've opened a door on the side, and they're about to install a new computer coprocessor for the Space Telescope's main computer. The old computer had lost about half of its memory banks, apparently because of some reaction from cosmic rays up in space, and it's going to have a lot more memory, and the main computer chip that will operate the computer is being upgraded from the 1970s technology 286 type chip to the at least 1980s vintage 386 computer chip. They couldn't put in the state-of-the-art material because the 486 computer chip, which most of our viewers probably have in their home computers if they bought new computers in the past year or two, just has not yet been qualified for space flight. But the astronauts are working very well together this morning. The main job that they had was to replace the optical system for half of the telescope's instruments, and that was done in about 2 hours, although the astronauts were allotted 3 hours and 15 minutes to do that job.
What kind of task will this new computer have? What is it doing on a day-to-day basis?
What it does is it stores information from the other instruments on the telescope and then sends them down to Earth when the telescope has time to transmit down through one of these tracking and data relay satellites. We have had the luxury most of the time that the astronauts have been out in the cargo bay of seeing their pictures live because the two tracking and data relay satellites that NASA has in orbit are most of their time is being devoted just to letting us see these pictures. But in a normal situation, if the Space Telescope were operating, we would only get about half these pictures because the maybe 20 minutes an hour is devoted to the Hubble Space Telescope. The intelligence community in the United States uses these satellites for perhaps 10 minutes an hour. When the space shuttle is up, it gets top priority. When it's on the ground, the other users get a much higher priority. And so the new computer will allow more information to be zapped back down to Earth during those brief periods when the telescope is directly in contact with the Earth. And what that means, according to the Space Telescope scientists, is we'll not only get better pictures from the new in-focus mirrors, we'll get more pictures because the computer will be able to store and retransmit more quickly more information. The astronauts are in darkness right now. They're operating from a spotlight, as you can see, and the computer compartment is about halfway up the side of the telescope. It's in a little door that they opened 30 or 45 minutes ago.
These astronauts are not just on the biggest plumbing mission, so to speak, of space history, but also this is a major public relations job, isn't it? I mean, that's also why we can watch all of this stuff live.
Exactly. NASA's new administrator, he's been the administrator for more than a year, Dan Golden, sent out directives to people at NASA that they wanted to let the world's people know what is going on when the astronauts are out in space. And he was very pleased to find out that CNN International was going to be covering this mission as much as we are. And you know, that's another reason that we get as many pictures as we get, certainly, because the people at NASA have two jobs, really. One is to convince the United States Congress to continue funding their programs, and so there's a domestic need, but the Hubble Space Telescope is an international project. The European Space Agency spends a great deal of time working on the telescope. 15 astronomers from Europe are participating in getting the data from the telescope and processing it and distributing it all over Europe. And that in addition to the United States astronomers and scientists who also use the telescope from time to time.
Now, the U.S. taxpayers who have to pay a lot of this plumbing bill, they are probably to a large degree fast asleep now.
Yes.
Why is the shuttle, why are the spacewalks scheduled for this time of the day? And I should point out it's like, for example, 2:45 now at the East Coast in the morning, so people mostly are going to be asleep. Why is the spacewalk going on now when it's really not great for TV audiences in the United States?
Well, there are a couple of reasons, Bettina. One, the most obvious reason is that the space shuttle had to be launched at a time from Florida in the southeastern United States at a time when the Space Telescope was directly overhead. And the only times during the month of December that it was directly overhead were at 3:30 in the morning or 4 o'clock in the morning Eastern time in the U.S. And if you're going to launch at that hour, you have to have the astronauts conditioned to be awake at that hour. And if they're already conditioned to be awake at launch time, then you want them not to have to recondition themselves after they get in orbit to do work much, much later when they'd be exhausted. They could have delayed the launch. If they could have gotten it ready several days sooner, perhaps 2 weeks sooner, then they could have launched in daylight and done all this work in daylight in the United States. But the scheduling people at NASA figured out that the soonest they could launch it was about the 1st or 2nd of December. They missed their launch on the 1st, but were able to complete it on the 2nd. And additionally to that, they couldn't have delayed much longer to do it because it cost a lot of money to keep all those instruments out there in the cargo bay in a place on the Earth where they couldn't get polluted. They're kept in a special clean room on Earth before they go into space, and the cost, and this is phenomenal to me, of operating a clean room and keeping this equipment in the clean room is $1 million per month. And so waiting 1 month would have cost the American taxpayers an additional $1 million, which NASA managers, I think, didn't think U.S. taxpayers would be too pleased to do. So this was the earliest they could get it up at a time when they could find the telescope without wasting a lot of rocket fuel, and also without having to pay exorbitant storage fees for the absolutely unpolluted equipment that they are now installing aboard the telescope. We can listen for a moment or two as the astronauts do their work to give you some perspective on this. The computer is about in the middle of your screen. Astronaut Kathy Thornton is on the robot arm at the left of your screen, and it's, I think this is sunlight beginning to come up on the crew. As that sunlight beams into the cargo bay and onto the side of the shuttle and the telescope, we ought to be able to see the computer. The computer itself is to the right of Thornton's hands and arms as she works there. So we'll listen as she continues to install this. The installation process, by the way, is pretty simple. They just mount it on top of the current computer, and then they have to hook up a power connector and a data connector that looks very much like the data connector on a home computer that we have. And it's got some small screws on it which are going to make the connection of that connector a little bit more difficult than it would be here on Earth because the astronauts wear such thick gloves. The payload commander, Story Musgrave, is in the crew cabin looking through the window and looking at this same picture that we are seeing on a TV screen in the inside the shuttle's crew cabin, and he's directing his spacewalking partners as they do this work.
Okay, Doc, can you bring me into the telescope about 6 inches, please? 6 points.
All right, there have been a couple of changes. Claude Nicollier, the European Space Agency astronaut who's been operating the robot arm, is taking a break and allowing his backup shuttle pilot, Ken Bowersox, to operate the arm. Nicollier very generous in allowing the American astronaut to spend a little time on the robot arm. It's made in Canada, and the Europeans are very happy that there's their astronaut in there, and he truly is being noble to let the American get a little use out of that robot arm. And the order of the astronauts is this. Thornton, on the robot arm, is in the brightly illuminated spacesuit that you see there. She has her arms around the upper legs of Tom Akers, her other spacewalking astronaut. So Akers has actually got the screwdriver in his hand. Thornton, on the robot arm, is holding on to him. Bowersox is operating the robot arm, moving the two of them in place to replace this computer.
Do they have like special equipment? We saw them earlier using, what was it?
Power tool?
Yeah, some kind of power tool. Do they have special equipment? How does that work?
Yeah, they have more than 200 different tools to perform various operations here. They have to use a very special tool for this computer repair because the screws on the computer connector are, as I say, just like they'd be on a computer connector on the Earth. I mean, just a couple of centimeters across. And if you imagine you're wearing boxing gloves, it's very difficult to hold an instrument that would be able to turn such a screw. So there's a special instrument that is adaptable to somebody wearing the boxing glove type equipment on their hands. And you can see the additional light in there. They're going to zoom in and let us look at this screw driving operation. You can see Tom Akers as he makes this effort. They're talking about turning these screws a half turn, and it's painstaking, very slow operation.
Now, of course, the two sets of astronauts, the two couples of astronauts that keep rotating on their spacewalks, they get all the international limelight. And then you've talked about Claude Nicollier. Who else is on board, and what are they doing while this is going on? And, for example, when the spacewalk is over, they all go to bed? Probably not, right?
Yeah, well, I think after it's over, they'll take about 2 or 3 hours. The ones who've been walking in space will take off their spacesuits. And that's a painstaking process, too. But, you know, it's not just the helmet, the top part, and the bottom part. Underneath that, they're wearing these suits with little plastic water tubes to keep their body temperature cooled. And they have to take that off, and then they're in sort of like long-handled underwear. They take that off, and then they can put on their civilian clothes. And they sort of decompress, probably emotionally and intellectually. We saw some pictures the other night as they ate dinner at about the time the sun was coming up.
But no beer to relax.
No beer at all to relax. It's too bad. When they get home, though.
It's a major party, out of this world party when they get home.
Exactly. I was talking to Ed Weiler, who's the project scientist, and he said, well, we're feeling pretty good about all this, but we're not going to have the big celebration until the telescope is back operating again, which won't be for about 6 weeks. But this mission, this operation, seems to be going very well right now. These two astronauts continue to do their work. They go to bed, generally, in about, 5-6 hours from right now. And they sleep until, for about 8 hours, and they're waked up and prepared to do the next part of this mission. But the NASA managers who I'm talking to, who won't say this in public, will say in private, they're ecstatic. This has been nearly perfect. And what it proves, they say, is that astronauts are going to be able to build the space station, which is something that the United States and the Russians and the Japanese and the Europeans are now all cooperating together to do.
Happens when you get comfortable hunting.
Okay, and that concludes for now our live coverage of the U.S. Space Shuttle mission trying to repair the Hubble Space Telescope. Thanks again, John, for coming over. We let him go back to CNN now, and we'll be back with world news in a short while. Stay with us. A long-distance greeting from the astronauts of the Shuttle Endeavour. Their efforts to repair an expensive telescope have met with more success. Also in the United States, the government has disclosed previously secret information about its nuclear weapons testing program. The revelations include acknowledgement of 204 nuclear blasts that were concealed to keep the Soviet Union in the dark about the U.S. arsenal. They represented more than 1/5 of all U.S. test blasts dating back to the 1940s. The information was revealed as part of a declassification of secret nuclear records. Officials also pledged to release information about radiation tests on hundreds of people. U.S. Space Shuttle astronaut Tom Akers took a few seconds out of his repair mission about an hour ago to wave a greeting to his family back on Earth. Akers and fellow crew member Kathy Thornton are well into the fourth spacewalk to repair the Hubble Space Telescope. Thornton and Akers installed a device called COSTAR, which is designed to allow Hubble's flawed lenses to focus properly. Astronomers around the world are eagerly awaiting word on the success of the Hubble repair mission. CNN's Tony Clark tells us about others who have a very personal interest in the project.
Edwin Hubble was a Rhodes Scholar and a Kentucky lawyer, but he's best known for revolutionizing astronomy. Hubble, who died in 1953, proved the theory of the expanding universe. It was his life's work.
He had that one aim. You know, he knew what he wanted, and he went after it. And he really had a lot of fine qualities.
Betsy Hubble is the astronomer's younger sister. At 88, she's the only member of his immediate family still alive.
On his 8th birthday, in those days, they had parties in the afternoon. And so grandmother asked him what he wanted for his birthday, what kind of a party. And he said he didn't want a party. He wanted to spend the evening with grandfather with a telescope that grandfather had made. So they stayed out that night.
Years later, Hubble went to England and studied law because astronomy wasn't offered.
When he was over in Europe, he sent me postcards. Because he had an idea he was going to train me.
Train you?
Yeah, like the English children. He thought they were really just superb.
When he returned home, Hubble taught Spanish, but astronomy remained his first love. He got a PhD and a position at the Mount Wilson Observatory. Betsy Hubble remembers when, as a child, her brother took her to look at the stars.
I stayed quite a little while, but I guess I got talked to. He brought me home.
Hubble's research is considered so significant, NASA named its orbiting telescope in his honor.
I think he'd be so proud. He would just be pleased, very pleased.
We may be in good shape.
Tony Clark, CNN, El Paso, Texas.
You're looking at a live picture from over 350 miles straight up in space from the Shuttle Endeavour. The Space Shuttle crew continues its space-bound repair job on the malfunctioning Hubble telescope. Everything seems to be going well. John Holliman is standing by, and we'll get to him moments from now. But right now, let us update you with what's going on around the country and around the world with some of the latest headlines other than And we are going to continue our coverage of the Space Shuttle Endeavour. John Holliman is standing by. John, you know the thing that I think about when I look at these incredible pictures that are coming back from space, we all take for granted the fact that everything is going right and everybody's smiling and it's all working out the way that NASA wants it to work out. But I don't think we should toss aside the fact that something could go wrong at any moment. And actually things are going great and everybody's happy, but there is the possibility that something could go wrong. This isn't a movie, right?
Nope, this is real life, Brian, and it's amazing that it is going as well as it is. Ed Weiler, who was the Hubble program scientist who was on the air with us here an hour or two ago, said that in a perfect world, NASA had a one-page mission plan for this mission with first night, second night, third night, fourth night, fifth night of spacewalk. And if everything went well, you could put all the answers, everything they had to do on one page. But beneath this one page was a 3-inch thick pile of documents with contingency plans for when things go wrong. Now here's a dramatic picture. Let's talk about it for a minute. Kathy Thornton and Tom Akers are out on the robot arm together. They've just backed away from an equipment bay in the side of the Space Telescope where they replaced some parts. Let's listen to Kyle Herring at NASA for a moment.
The crew today will be to use some of the scissors they have to cut some multi-layer insulation away from the wide field and planetary camera protective enclosure, one of its latch covers. They will take that insulation into the middeck at the conclusion of the spacewalk, and they will fashion some new covers for the telescope's old magnetometers that were bypassed yesterday during the third spacewalk.
Go ahead.
You'll remember, if you were with us at this time last night, when the astronauts went up to replace or add to the magnetometers that helped the telescope find the Earth's magnetic field, they found that metal boxes over the electronic units for one of the magnetometers had come off. And so what they've decided to do is take some material from the old wide field and planetary cameras insulation that's down there in a storage locker and cut out a little chunk of that insulation and put it over these magnetometers up at the top of the Space Telescope. To tell you the truth, I believe the astronauts probably just want to go back up on the end of the robot arm 50 feet above the cargo bay and get the view of the Earth that they're going to get as the Endeavour comes back into daylight with the Earth below it. The picture you see right now shows that it's over the Earth in darkness, so you can't see the planet below, unless you might see a brightly lighted city zoom by the wings, because you can see planet Earth there off the right-hand wing of the shuttle. We have some phone callers who'd like to get in and participate in our conversation. The first one from Saskatchewan. Go ahead, you're live on CNN.
Yes, Ed Bettler from Prince Albert, Saskatchewan calling. The question I would like to ask is that the way they're going there, that a building of a space station would seem to be in the near future. Now, the foot-pound inertia of sending a ship from Earth into space what would the saving be of sending one from a space station on these missions and further missions out into space?
It's a good question that I don't have even an inkling of an answer to. I'm sure it would be easier to launch something from 300 miles up because you wouldn't have as much of the Earth's gravitational field to interfere with what you're doing. Michael, do you have an answer?
Sure. Basically, if you're at least 120 miles out into space in orbit around the Earth, you're halfway to infinity. You need about half the energy to get up into orbit and to get up to 17,500 miles an hour. And then if you want to go all the way to the Moon or to Mars or Jupiter or any other place in the solar system, or even if you want to boost a spacecraft out of the solar system, you only need half as much energy. What's more important, though, is that once you're above the Earth's atmosphere, you don't pay the terrible price in drag and wasted energy getting up above the atmosphere. So once you've gotten out into space, it's really very easy to go to other places and to come back from other places. There are places in the solar system, for example, the Moon, where it's much, much easier to escape from. With a really strong catapult, you can actually launch a person, a ship, a rock, anything you want, right off the surface of the Moon, all the way back to the Earth. So it's most of the energy that's being expended, most of the energy that's being wasted on all of these missions, unfortunately, is in the first 10, 20, 30 miles of atmosphere.
Our next caller is from Alberta. Go ahead, please. You're on CNN.
Yes, I have a question. First of all, I have to say thanks to CNN for their superb coverage and to their panel of expertise there. It's amazing coverage, and I really enjoyed it a lot. My question is, when Kathy Thornton released the panel, they said it would fall back to Earth in approximately 1 year.
Yeah.
Is the Hubble, does that have a chance of doing that?
No, it doesn't. One reason it doesn't is because the shuttle astronauts are going to boost it into a slightly higher orbit before they let it go 2 days from now. At the angle that it is going in space, it can stay there for a while. It's one thing about this panel that's different from the Space Telescope is that now that it is free floating in space at the speed that it is floating, it virtually has to come back to Earth within a year. The telescope itself, I believe, is traveling at a higher speed, which is one of the reasons that it's able to stay up as long as it is.
Well, there's only a small difference in speed, but the difference between the panel and telescope is more or less the difference between, say, a piece of tissue paper tossed out of a car and a brick tossed out of a car. The brick is going to keep on going for quite a ways before it hits the ground. The tissue paper will stop dead almost immediately. There's only a little bit of residual atmosphere up there, but the larger size to weight ratio of the panel, the fact that the panel is so big but doesn't weigh very much, slows it down very quickly, and so it'll tumble back to Earth quickly, whereas the telescope is much more compact, and as a result the telescope will keep on going. Even if the astronauts were not to boost the telescope, it would remain in its orbit. It would be stable in the orbit that it's in for about 5-6 years before it tumbled back to Earth. With the boost, it's going to stay up longer than that.
All right, our next caller is from Virginia, and we have more live pictures from space. Go ahead, Virginia.
Yes, Wallace Barnes. Wanted to ask a question. Is it possible, rather than having a single Big Bang theory, a infinite number or a series of continuous bangs that would level out the background radiation?
That's an important and really difficult question that astronomers and physicists have been struggling with since Hubble's time. When it became clear in Hubble's time, almost 70 years ago, that the universe was expanding, the question was immediately asked, well, does that expansion continue forever or does it stop? And we really expect within the next 3 or 4 years to be able to answer that question, or at least put much tighter constraints on the possible answers. Now, if the universe does stop expanding, if there is enough matter in the universe for the universe to stop expanding and then to fall back in on itself, there is the possibility that that cycle could repeat itself over and over and over again. Now, we think that the background radiation that we see in the universe is the remnants of the Big Bang.
All right, Michael, thank you very much for your commentary so far this evening. We're going to take a break. CNN Newsroom coming up with a very special report. We'll be back and we'll wrap up the last phase of this mission coming up very shortly here on CNN. Stay with us. We'll keep you posted.
And it allows us both to analyze the chemistry of stars and galaxies very, very precisely, and also allows us to measure the velocities, the speeds of stars relative to us extremely precisely. The second critical thing that has got to go right tomorrow is the unfurling of the solar panels. The astronauts certainly want to be around for that. If for whatever reason the panels don't come cleanly open, they can lend a manual assist and get them open too.
Now,
but at this point, we're in great shape.
Yeah, those solar panels work great on the ground, don't they? I mean, when they test them out in the laboratory, they close up and open up just right. I wonder what happens to them between the time they're in the laboratory down here and they're in the shuttle up there.
Well, I think that's proof that Murphy's law applies in space just as well as it does on the ground. Anything that can go wrong will, and at the worst possible moment. Any slight stiction, change in temperature, change in who knows what, can cause things to foul up. There are enough safeties built in so that the panels won't force themselves open too violently and won't destroy themselves, and we do have the astronauts there to lend a hand if necessary.
As a scientist who uses the Hubble Space Telescope a good bit of the time, how difficult is it for an astronomer who wants to get time on the telescope to do so?
It is highly competitive. You have to write a good proposal and you have to pass muster by your peers. It's not me or any other one astronomer at the Space Telescope Institute who says that proposal gets time, that proposal doesn't. We have a whole panel of experts who sit and read through all the proposals and deliberate very, very hard about what the best potential science is. Sometimes they take a gamble. They may allow some proposals to go on that perhaps only have a 50-50 chance of success, but will give us spectacular results if they do. There are some proposals that are, we're pretty sure they're going to be successful, and some that are occasionally even far out that are tried on the telescope. It is a highly competitive process.
I want to see some more of the pictures you brought from the Space Telescope Science Institute.
This is a ground-based picture of our nearest big galaxy neighbor. That's the Andromeda galaxy, M31. And you can see in the upper right corner, Andromeda has a satellite. And then just below Andromeda, near the center of the picture, there's a second satellite. Each of those satellite galaxies is made up of about 10 billion stars, while Andromeda is made up of 200 or 300 billion stars. One of the most interesting places in Andromeda is dead center, right in the middle of Andromeda. The next graphic is another ground-based picture which shows what the central nucleus of Andromeda looks like. There's a very, very bright point-like nucleus. That bright point of light is made up of at least 10 million stars. Swirling around themselves, and up until this year we thought of the nucleus of Andromeda as being that one central point. But a picture with Space Telescope recently, shown in the next graphic, shows that in fact the nucleus is really made up of 2 points of light, and that's seen even better in the next graphic, if we can have that please.
Wow.
Which shows that there really are 2 nuclei right in the center of Andromeda. This is a discovery that was made with Space Telescope. We just never knew that this was true from the ground, and astronomers are hotly debating what it means. Are there really 2 nuclei just at the center of Andromeda? Do other galaxies have that sort of phenomenon? One possible theory is that Andromeda is cannibalistic, that it has eaten one of its nearby neighbors in the last, million or few million years, and that the double nucleus you're seeing is really the original nucleus of Andromeda plus another nucleus.
All right, Michael, as you were talking, we got back to live picture from the cargo bay of Endeavour, and I'm not sure which of the 2 astronauts this is. I see that the footrest on the robot arm is now empty, so it could be either astronaut. Whichever astronaut this is wrestling with the end of the robot arm, trying to attach a tether to it. Maybe we should listen in to NASA Select for just a second and try to figure out what's going on. Okay, they're being quiet while this astronaut gets the tether line attached to the end of the robot. Okay, let's listen. I can tell you this, one of the astronauts is in the airlock, and I believe it's Kathy Thornton who was outside, and no, I believe it is Tom Akers who was outside, and Kathy Thornton might already be in the airlock. Okay, we're going to take a quick break. We'll come right back, and hopefully we'll have more pictures like this, and we should be able to see a spectacular sunrise over the Earth as part of our coverage. Stay with CNN. We'll be right back. We'll take you quickly back to Endeavour. You see the airlock door there. Astronaut Tom Akers, the last person into the airlock. Kathy Thornton's been in for a couple of minutes already. The airlock is not a very wide compartment, so the astronauts have to sort of compress themselves as they go inside. Let's listen for the last moment or 2 of conversation as the astronauts go back in out of space.
Hey, what is up?
A bright picture as the sunlight from the sunrise comes into the cargo bay. The robot arm is visible on your left. And the astronauts are now zipping up the thermal cover on the right of our picture, the right of your screen. They're out in the cargo bay of Endeavour as the shuttle gets more and more in sunlight over, actually they're over the ocean on the west coast of Africa right now, but the sun is steaming in there and the cameras in the cargo bay having a hard time compensating for that bright increase in sunlight. The spacewalk started at about 15 minutes past 10 Eastern Time. It is now 3 minutes until 5 Eastern Time, and so they've been outside for quite a while, more than 6 hours, I would say. And the spacewalk that is going to start in about 16 hours from now.
Now inside the orbiter.
We'll listen to NASA's commentator.
Kathy Thornton just wrapping up today's spacewalk. Time of the spacewalk thus far, 6 hours and 45 minutes. They're now in the process of closing the hatch cover, the outer hatch of the orbiter Endeavour, and will soon be hooked up to the orbiter's internal system and ready for the repressurization of the airlock. The airlock is depressurized down to the vacuum of space before they go outside. And once inside
Michael
the
Sherrill, we
airlock
have about
and the hatch is
45
closed,
seconds left for our live coverage here. I'd like your thoughts as an astronomer, having seen what you've seen over the past 6 hours and 45 minutes.
This has just been absolutely uplifting. Those guys have gone out there and done everything they had to do. They did it professionally, they did it quickly. It was a great show, and they have given us back our telescope. We really have the ability to go and do the cutting-edge science that we so badly want to do.
All right, thanks very much for joining us tonight. You'll be back with us in about 16 hours. I hope you get a good night's sleep. And for our viewers who've stayed up all night with us, a remarkable evening, a remarkable early morning hours here at CNN. Thanks for joining us. We'll see you again in a few hours.
They've been called mechanics, furniture movers, and orbiting opticians, but whatever the job description, they have risen to the occasion.
There it is, just like the pictures take you.
The pictures were once again out of this world as the floating Hubble Fix-It team of Kathy Thornton and Tom Akers gently installed a refrigerator-sized box containing prescription mirrors, which should give the Space Telescope 20/20 vision.
We've got basically a new telescope up there, and it can be
They've been called mechanics, furniture movers, and orbiting opticians, but whatever the job description, they have risen to the occasion.
There it is, just like the pictures take you.
The pictures were once again out of this world as the floating Hubble Fix-It team of Kathy Thornton and Tom Akers gently installed a refrigerator-sized box containing prescription mirrors, which should give the Space Telescope 20/20 vision.
We've got basically a new telescope up there, and it can be real exciting for the astronomical community, I guess, and for the whole world to see what Hubble really can do with a good set of eyeballs.
But first, spacewalkers Jeff Hoffman and Story Musgrave may have to work on Hubble's brain. A computer installed piggyback over the telescope's existing computer last night isn't working properly. It may require the astronauts to check the computer connections tonight.
If we do have the same problem, at that point we can disconnect the coprocessor, and we're no worse off than we were when we started.
But if the main computer is the culprit, NASA may schedule a 6th spacewalk to install the spare Endeavour is carrying. Hoffman and Musgrave also plan to replace a failed backup control unit for the solar power arrays. These boxes were not designed to be replaced in space.
There's some very small bolts that hold that box to the telescope, and they have to be removed and captured with a gloved hand.
That one looks good, Sox.
They also have time to add a chore to their list. These improvised foil covers will be wrapped around some gravity-sensing magnetometers, which were found exposed on an earlier spacewalk. Then the space workers will go to the base of the telescope to attach a device which should make an ultraviolet light sensor more reliable. With the most crucial objectives of this high-risk, high-stakes mission accomplished, Endeavour's crew took time to play around and see the sights. Spirits are soaring in orbit and on the ground.
And we're going for a slam dunk.
Yes, it is extremely difficult to keep from getting excited right now, but I gotta try.
NASA has been burned before when high hopes for Hubble became deep disappointment. So until the telescope can be fully checked out, Endeavour's crew won't rest easy.
I certainly will not relax until 6 weeks or 2 months from now, when we see how the solar rays perform, we see how the towers perform, we start getting optical images back from all the instruments and see if the aberration is corrected.
The job may not be done, but the hard part may be over. Miles O'Brien, CNN, Atlanta.
Well, it's getting daylight, KT, so I guess we can get our lights off.
Crews now getting their work sites set up, getting their tools in order, and making sure that all the tethers are in place. During the spacewalk, the crew can be distinguished from one another by the fact that Mission Specialist Kathy Thornton will be riding on the arm, while Akers will be free floating. In addition, Thornton's suit has a broken red stripe around the legs, while Akers' suit has a diagonally broken red stripe around the legs.
Sure can. Thank you.
James, one of the things we've been able to enjoy watching is the choreography between the crew member operating the mechanical arm and the person that's out on the end of it, as Kathy is here. The Canadian-built mechanical arm with a foot restraint in it is a marvelous way to do business. If we didn't have that functioning or available to us, we would have to have foot restraints placed throughout the payload bay, and the crew members would have to get in and out of those and kind of leapfrog the handling of the various different instruments to and from this telescope as they're doing their work. This saves a tremendous amount of time.
Later, right?
We copy.
Stand by, KT, please. Just hold it there. Are you ready to go, KT? Yeah. Okay, swing it.
Yeah, do you want to grab, Tom, you want to grab the other one?
I'll keep swinging.
Can bring me back just a little bit, please?
Okay, swing it if you can.
Okay.
Okay, I'm here.
Got it?
Yep, I've got it. Let it go.
Hey, let's chase the port one, Clark. Hey, let's pull open this. Okay, stop.
Stop. Okay, it came loose. Tether them all together down. Okay, you've got about 2 feet to go, and you're looking real good. I just keep going, KT.
Hey, keep coming, Clark. Good rate.
Perfect. Perfect. I just keep straight on going. Looking good. You hold down on it. Now you're starting to come off the rail, so take everything out. Okay, you're free of the rail.
Hey.
Okay, you're pitching back in a little. Pitch up a little.
Coming, Clark.
No, pitch up a little too. Just keep going. Keep going.
Coming, Clark. Keep.
Okay, you're clear of the cavity. Yeah,
Okay,
increase the rate somewhat here, Kitty. Okay. Good. Yeah, the top's pitching toward me a little bit, KT. It came out. Better right there. Okay? Looking good. Why don't we stop right there, KT? I'm comfortable with that.
Stop here, Clark.
Okay, stopping start. Let me see if I can get in position to watch you come back in within about 6 inches or so, and we'll look at it. Didn't touch anything coming out of the shroud there. It was good. I'm going to ease back. I'm going to slip over. You got another foot to keep coming up.
Hey, I can't see anything anymore. It's your call.
Keep coming up, coming up, coming up. Keep coming, Claude. Straight on up. Take her little port, Claude. Take the port. Not yet. Okay, good. Stay where I am now. Oh, I have to. Good. Then I have good clearance. Close the lid. Oh, this is so nice, KT.
Endeavour Houston. Endeavour Houston, minute and a half to LOS. Be back with you on the west. 1954.
Okay, Greg. Much daylight we got left? Not much, Store? 42 minutes. Oh, coming. All right.
How much?
42 minutes.
I'm going to turn my lights on anyway.
Okay. I think I still have one on. I took it off when we were doing the B-latch. Well,
Stop right here a second,
I think you can do this.
No, I think I can too.
I'll go to the ASAP door.
Do we have to go to the front and close it out now?
Yes, sir, Store. You can completely close the doors now. Greg, thank you. Yes, we did, KT.
Okay.
I think everybody's going to breathe a sigh of relief.
I think we could have swum around and done GHRS in there without opening the door.
Don't say that. We've heard that before.
Endeavour Houston, we've got a good shot of you, Tom, from the elbow if you want to wave to Kay and the girls.
Say again, Greg.
I was just saying that we got a great shot of Tom there. We can see his face very clearly. I thought he might want to wave to home.
Oh, so I'll lift the top one and then I'll come back to the handle.
Good for out, now right. Coming open easy. There it is, just like the pictures, KT. Okay, let's go into the telescope, Claude. Okay. Roll me down a little more. I know we're going to need that when we get to... Okay, that's yours. Okay, I really rolled just out time. I think you have to be pitching me down, but just roll right. Okay. Hey, sorry. Yes, there was 42 turns it took to get this guide set out. I counted them. Believe me? No. That's twice as many. Felt like 42. Okay, I'm just starting each of them a couple of turn stories. Make sure I'm lined up. They're all starting. Okay, story. Feather to it, ground wires cut. Peeling down slowly. Okay. From the A flat side. Not touching the sticky stuff. My gloves. close this pretty picture up, KT. We're closing the thermal cover story. I'll get her water next. Is that right? You want to read us the rescue card? I'm getting the thermal cover now.
I do have some good news for you, Jeff, and for everybody. The payloads folks informed me that the DF and the coprocessor have gone through a complete checkout and are fully functional.
Great news. We're almost home free.
That's right. The way I see it. Go ahead.
We've got basically a new telescope up there, and it's going to be real exciting for the astronomical community, I guess, and for the whole world to see what Hubble really can do with a good set of eyeballs.
Endeavour Houston, more good news. Coprocessor is checked out, fully verified.
Yahoo! And that comes from the mid-deck.
This is Mission Control Houston aboard Endeavour. At present, the crew is just a little more than 5 minutes away from an engine firing that will serve to reboost Endeavour and the Hubble Space Telescope, raise the orbit to a circular orbit of 321 nautical miles above